3, 2, 1. Peter, we cannot hear you right now, so you need to unmute yourself. Yes. Now.
I need to unmute myself. So now, starting over again. So hello there, and welcome to DevFest 2020. I'm glad a lot of you guys have joined, and from the comment section in YouTube, I see there's people from all over the world. So welcome. So I would probably see a lot of new faces, but it's 2020. So that's that. So this event is probably our biggest event we ever did, with 5,000 people that signed up for it. The only other event we had that was, of course, in person was about 400 people. So that just gives you an idea how big GDG Silicon Valley is. We also got 5,000 new people for this event that signed up in the meetup group. So that's a pretty big game. So that's also just a little side note. But here we start, right? So my name is Peter. I'm one of the organizers. And so we have a group of 3 organizers right now. One is Tracy and the other one is Andy. And unfortunately, they couldn't join us today. But we hope to have them back soon for other events. A bit of the organization for today. Most of you already saw that. We have an agenda either on Meetup or the GDG community site, and we have 2 tracks. So there's a little bit of fiddling around with that, but they should be fine. So that was basically my introduction. The only thing I want to say is, that I really miss pizza. So, usually we have events with pizza, and I really miss those in-person events, and hope to see that we will go back soon next year to meet in person in our usual locations. So with that, I hand over to Corina and to Kubra.
Cool. Thank you, Peter. This is amazing. Like, welcome, everyone. I'm really excited about this DevFest. So like Peter said, actually, like we haven't had any such a big event like this. So yeah, my name is Kubra Zengin, and then I'm the regional lead for North America developer communities at Google. And I've been working with developer communities for US and Canada for 3 years almost. So far, and I'm really excited about networking with developer communities, just working with them on making the world better. We say it right. So I see lots of people joining from around the world. Perfect timing, perfect content that we have. There's a great lineup. So welcome, and then I will just introduce my teammate Corina to just take it over.
Thanks, Kibra. Hi, everyone. Thank you so much for tuning in today. Hope you all are staying safe and healthy wherever you are. There's so many people joining from all over the world that I'm seeing, and it's super excited to have you all here today for DevFest Silicon Valley. So as she mentioned, my name is Karina Liu, and I'm currently on the Google North America Developer Ecosystem team supporting the GDG and WTM communities. So DevFest is always a special time each year where we bring together our GDG communities to learn, connect, and there's lots of great talks and speakers today that we have lined up for you. So we're super excited about that. So hope you all enjoy, and feel free to connect with one another on the YouTube live chat. And with that, I'll hand it over to Vikram.
Hey, everybody. Thanks for joining us on the live stream. Once again, welcome to the DevFest. My name is Vikram. I run a startup in San Francisco where we are building solutions for the personalized automation. But for today, I'll be your host on the main track. Me and Corina are your bridge between amazing speakers and you on the main track. You can ask questions in the YouTube comment section, and our team will either answer them in the comments or we will ask them directly to our speakers on the video. Remember that we have and follow our code of conduct. The link to the code of conduct is shared in the video description. But in short, just be nice to each other. As we get started, could everyone let us know in the comments where they are joining in from and what sessions they are most excited about? So we are all here for DevFest, but what is this all about? Let's get started by taking a quick glance at what DevFest are all about, what we have done in past, and what we have in the future for the store, for us.
Thousands of developers who are working to address real-world problems in their local communities. Particularly during the challenging times of COVID, I'm impressed by how much your work has made people's lives better. There's a few recent examples that truly stand out to me. Community developers from GDG West Sweden recently worked with the Swedish government to create Hack the Crisis, an event focused on designing, testing, and executing ideas in response to recent challenges. One of the finalists, named Remote and Gigs, helped modernize the Swedish government's employment website to match job seekers with remote work. Nearby in Romania, GDG groups organized a hackathon, gathering 270 different mentors and students from across 8 different countries. The hackathon brought together developers to save lives, to save communities, and to save businesses. Some of the winners included an online platform that connected volunteers with nonprofits across the region, a system to help doctors work with each other and to ease online consultations, and a personal assistant for health and nutrition tracking. Another cool app that they developed was Risk Alert, an app that alerts emergency rooms that a patient with a very rare disease is about to arrive, so that the hospital can prepare for any special needs. In Asia, GDG Tainan initiated the Mask Inventory Map at the start of COVID-19, which crowdsources mask inventory from local store data, combining it with the Google Maps API. The project was so popular that it caught the attention of Taiwan's government, inspiring them to publish public data APIs on mask inventory, managed by the government. Taiwan's digital minister has since encouraged the GDG Tainan chapter to create more than 100 different apps to help the local community. In India, GDG Cloud Pune used machine learning with TensorFlow and GCP to help their community with an app that remotely analyzes dental health and helps patients book at-home dental services. They've had over 300 trained images so far, and the developer community is working with local universities to gather more than 50,000 dental images to improve the application. In the Middle East, the region's largest International Women's Day event was held in April in Turkey by multiple GDG groups working together. They had over 2,500 attendees to the event, which included a raffle for online courses and talks in artificial intelligence and data mining. The event helped women across the community and across the region learn and apply their skills. And of course, here in the United States, the GDG Memphis chapter has joined GiveCamp, where software developers in the area donate their skills for nonprofits, as well as helping kids learn to code on the weekends. These are just a small sample of the ways that Google Developer Group chapters and communities like yours all over the world are learning together and giving back what they've learned to really help people's lives everywhere be better. I encourage all of you to continue, be in community with your fellow developers. Think about how can you use the skills and the tech that you're learning this weekend at DevFest, as well as the networks and the communities that you form, the new friends that you make. How do you combine all of these to make a difference in your own area? Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture. But when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozesako ddagala okulaba nti akako okulya ki kasooli naye akantu ako tekayinza kumalawo obulwadde obwo ssebo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eyes, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do, but then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm. ultimately saving harvests and reducing pesticides.
Kunkyusizaamu kubanga taata oba jjajja teyalina ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetoonya. Tulina essuubi ne tufuna embeera ennungi mu kulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. Farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video about how machine learning and Android were used to create an app to detect crop diseases. So for DevFest, I wanted to get together a few of my friends from Google and beyond to show you how you could get started in building something just like that from scratch in a few minutes. We'll build an Android app and a web app. So to get started with Android, let's see what Chet can teach us.
I want to create an app that's able to recognize information about plants. It's going to need camera functionality as well as machine learning inference. Let's see what that looks like in code. The app is written in Kotlin and uses Camera X to take the pictures and MLKit for on-device machine learning analysis. The core functionality is in Take Photo, where we take a picture, analyze it, and display the results. First, we call Take Picture on a Camera X image capture object that was created earlier. One of the parameters is a callback object, which has this on-capture success function. We get the received image into the format we need for MLKit, then we create an image labeler object and process the image. When this succeeds, we receive a collection of image labels, which we turn into text strings and display a toast with the results. Let's see what the demo looks like. So we'll take a picture and it says, I see an insect and a plant. So that was pretty easy, rigging up Camera X and MLKit to detect arbitrary objects in the camera view. But the results were pretty generic because the data set didn't have enough information about our domain. So let's dig a little deeper.
Okay, let's go deeper. Now we need a model for something very specific, detecting diseases in bean plants instead of cassava. Let's explore how to build it. On this guide, we will use some of the great TensorFlow tooling available. Let's start with Colab. You can understand Colab as a cloud-hosted development tool. We will do all our coding on it, and you will not need to install anything on your machine. Let's start with a new notebook. Let's just turn the title to beans. We will need to install some packages that we are going to use later. These packages are not installed on your machine. They are on a cloud machine that was created for your Colab. Nice, it finished installing the packages. Let's download the data and do some visualization to understand how our data is separated. Perfect. We download the data. Let's take a look on some of the images so we can have a better understanding of what we are doing here. Here they are. These are some of the images that will be used for training our model later. Now we have the data. We need to create a model. We are not going to create one from scratch. We are going to use a technique called transfer learning. TensorFlow Hub is a repository for TensorFlow models. You can find all kinds of models here. Let's start with this one. Let's go back to our Colab. Let's define a model handle. Nice. Now we have the data and the base model. How can we do transfer learning? To do that, we are going to use one of the tooling that I mentioned before called Model Maker. Model Maker makes your life way easier when you need to do transfer learning. Let's create the spec for our base model. Let's create our training variables here using the dataset beans that we've just seen. And now we are going to put everything together with Model Maker by defining a model with the training data and the spec that we got from TensorFlow Hub. This will take a couple of minutes. It finished training. And as you can see here, our accuracy is at 87%. Of course, let's evaluate the model with some data I didn't see yet and see how good it is. Nice, 95%.
The TensorFlow Lite model Gus just created contains all of the metadata Android Studio needs to recognize it and automatically build classes for it.
To get started, you can update your build.gradle file to include the following TensorFlow Lite dependencies: Then, you'll want to import your generated TF-Lite file into the ML folder of your project. Let's check out the details of our imported model. From here, we can see an example of how to use the model in our app. Let's move over to the main activity class to take advantage of it. Inside of our image capture callback, here on line number 78, we create an instance of our model. Next, we use it to process the captured image here on line number 84. And finally, here on lines 92 through 98, we display the results of consuming the output inside of a toast message. Let's run our app. Now, instead of telling us it's looking at a leaf or a plant, it can actually tell us if it's looking at a bean leaf and give a diagnosis. Sweet.
So this concept works, but it's very much a raw demo. What if we want to make this a more successful app? Well, we'd probably need to add services like authentication so our users can sign in, analytics and A/B testing so we can find out how our users are really interacting with our app, some crash reporting or performance monitoring, and an easy way to save our users' data to the cloud. Luckily, that's where Firebase comes in. Now, the new and improved Firebase plugin in Android Studio makes this simple. I'll start by adding some analytics so I can find out exactly how our users are interacting with our app. And the plugin does most of the work to get the library integrated into my project. Now that I've done that, well, we can get an instance of the library up here, and then we can log what kind of results we're getting from MLKit. And then once we've done that, there's a lot of ways to get at this data. It'll start showing up here in the Firebase dashboard, but I find one really fun way of viewing this data is to use Stream View, which kind of gives you a real-timey sample of what kinds of analytics results we're seeing. Looks like I've already recorded several of these select content events, and I can dig into these event properties and see what kinds of results our users are getting. And I could start using that information to maybe refine my MLKit model or A/B test different alternatives. Firebase helps you build better apps, and analytics is just the tip of the proverbial iceberg. Maybe we could let our users upload their own pictures and store them in the cloud using cloud storage for Firebase. There's so many possibilities.
This is a sample app, but if we were to productize this, it's important to keep in mind how our AI design decisions impact our users. For instance, we need to consider if and/or how it makes sense to display confidence intervals to help your users interpret the ML model output. Or say how you design the onboarding experience sets user expectations for the capabilities and limitations of your ML-based app, which is vital to app adoption and engagement. For more guidance on AI design decisions, check out the People Plus AI Guidebook at pair.withgoogle.com/guidebook. This use case focuses on plant diseases, but for other use cases where our ML-based predictions intersect with people or communities, we absolutely need to think about responsible AI themes like privacy and fairness, which you can learn more about at tensorflow.org/resources/responsible-AI.
And don't forget about the web. I built a PWA that can be installed across all your users' platforms. It combines the web camera with TensorFlow.js, and by integrating machine learning, we can make an amazing experience that runs across all browsers. Now let's take a look. We have our standard project layout with a HTML file, a manifest, and a service worker to make it a PWA. We have some styles to make it look good, and our data folder that contains our TensorFlow configuration and trained model that we're going to use in the app. Now to the heart of the project, let's go back to the HTML file and see what's happening. We're also loading a webcam object. This is just a class that wraps some boilerplate logic to make it easier to pass camera data from getUserMedia to TensorFlow. And now let's dive into our app logic in index.js. So I'm just going to use Chrome and the debugger here. And this is only so you can kind of see how easy it is to integrate machine learning into your application. So let's get started by clicking the classify button, get the machine learning gears into action, and immediately we break into the TensorFlow tidy function. This is just there to help you kind of clean up any of the memory that TensorFlow uses whilst it makes a prediction. We get our image from the web camera, and then we pass our image back into the machine learning algorithm to make it a prediction. And once we've got a prediction, we access the data, and then we can use that data to update the user interface kind of based on any application logic that we want. And that's pretty much it.
Great. So now you have the platform for building a real app. With the tooling from Android Studio, the APIs from CameraX, Jetpack, MLKit, Colab, TensorFlow, Firebase, Chrome, and Google Cloud, you have a lot of things that just work better together. This isn't a finished project by any means, just a proof of concept for how a minimum viable product with a roadmap to completion can be put together using Google's developer tools and APIs.
You might also want to open source this project too, so developers can suggest improvements, optimizations, and even additional features by filing an issue or sending a pull request. It's a great way to get your hard work in front of even more people. We'd love to help you with this, and you can learn more about the process at opensource.guide/starting-a-project. Indeed, we've already open sourced the bean disease sample we discussed in this video, so you can have a great place to start.
Thanks, Pooja. And as you mentioned, open sourcing a project is a great way to make it grow and inspire people to adopt and extend it. If you want to learn more about what you've seen in this video, please visit us at developers.google.com.
Hi, developers. My name is Annie Jean-Baptiste, and I'm the head of product inclusion at Google. The demo you just saw shows how Google's products can come together to create an amazing app. But what about product inclusion? You may be wondering, well, what is product inclusion and why is it important? At Google, we believe that giving power to new voices is the core of innovation. When we bring an inclusive lens to the product design process, we amplify underrepresented voices and allow all users to feel seen and validated in the moments that matter for them. We look beyond ourselves and seek out diverse voices to shape the products that we build. We also believe that we have a responsibility not to disappoint our users, no matter who they are, what they look like, how much money they make, who they love, how old they are, or anything that makes them them. And when we make difference the new normal, we will usher in new opportunities to grow our business by earning the love of all of our users. So whether you're 1 or 105 years old, live in a city or a remote village, on Wi-Fi or cellular service, Google is there for you to make sure you have the answers you need when you need them. Product inclusion is exactly what it sounds like, bringing an inclusive lens throughout the entire product design process to create more inclusive products for our users. And so when you're developing your own apps, I challenge you to incorporate the principles of product inclusion into the design process, because we believe that you can do well and do good by being intentional about including underrepresented voices at key points in the product design process. Remember, those closest to the problem are also closest to the solution. You can learn more about product inclusion at Google by visiting accelerate.withgoogle.com. Thanks.
Hi, everyone. My name is Jen Cole, and I'm the Global Developer Communities Program Manager at Google. Now it's time to meet and hear from your local developers. So, what can you expect next from your local DevFest? We'll have technical talks, breakout sessions, networking opportunities, and more. These sessions will cover a variety of technologies, such as Android, Google Cloud Platform, machine learning with TensorFlow, web, Firebase, Google Assistant, and Flutter, with speakers from Google, women tech makers, Google developer experts, and your local community. Be sure to claim your badge for participating in DevFest 2020 by going to google.dev/DevFest2020. You can earn even more badges by mastering different Google technologies available on developers.google.com/learn. As a reminder, one of the most important parts of DevFest is providing an inclusive and harassment-free experience for everyone. As an active participant of DevFest today, we can all agree to treat everyone with respect and to speak up if we see or experience harassment of any kind. Together, we can create an environment that is welcoming and inclusive to everyone with us here today. Follow @GDG on Twitter for highlights from DevFest around the world, and try out the DevFest AR filter and avatar. Share what you're learning or your favorite part about the event on social media with #DevFest. And lastly, don't forget community is all about getting to know one another. Use the virtual breakout rooms and chat feature to connect with other developers near you with shared interests. We hope you enjoyed DevFest 2020.
Every time I watch this video, I get so fired up and inspired to do more things. Let's do this. So for today, we have 2 tracks. This is the main track, and we have another track, and a link to that is in the video description. Take a look at the sessions that you want to attend and join the correct track. You can always switch around to another track after a session or in between the sessions. We'll wait for 5 minutes here while everybody is switching their tracks, and then we'll get started. So, welcome to the main track. This track is full of dog owners. First up, we have Cookie's mom, Nilay. Nilay has been passionate about communities and started her journey as a GDG organizer and WTM lead in Istanbul. Now, that passion has led her to being the program manager for Flutter developer relations team at Google. Let's welcome her with a round of words in the comments. All yours, Nilay.
Hey, sorry, I was speaking and I just saw that. Oh, you are on mute, Nilay. Sorry, thank you. Hi, everyone. You didn't miss too much. Can you hear me now? Is everything okay? Okay, cool. Okay, sorry again. Hi, everyone. I'm so excited to be here today. My name is Nilay, and I don't know if all the viewers are from Silicon Valley, Bay Area, or all over the world. I don't know. But for those who had been to any of the past GDG Silicon Valley meetups, maybe 2 years ago, they might remember me in the Google office because I was hosting the meetups as GDG Silicon Valley and San Francisco meetups in the Google office. So you were seeing me every month. We were seeing each other. So I had a lot of familiar faces, even though we may not remember all the names, but we were knowing each other. So if you're here, hi from me. So yeah, I used to work in that GDG North America team, but now I'm in the Flutter team in 2 years. There are new people, new awesome people in the GDG team. and I continue as a program manager in the Flutter developer relations team. So today I'm going to talk to you about Flutter. So what Flutter is, how it works, why Flutter, why Google brought a new technology called Flutter, and if you're interested in learning Flutter, what you can do and what will be the journey for you. So today this is what I'm going to talk. And for those who don't know me from the GDG Silicon Valley, so I am Nilay, and I am originally from Turkey. So this is a Turkish English accent. And I moved to US 5 years ago. And then I joined as a community manager at Google like 5 years ago. I was working with GDG North America teams. And then after 2 years, I joined Flutter team as a full-time Google employee, and now I'm in Flutter. Now, if everyone is ready, I can actually start with my presentation. Can I get my slides back, or are they? Can you see it? I don't see my slides. All right, someone tell me if I can start or not, because I don't see my slides on screen. But if you're okay, I can start. Okay, anyways, while my slides are on the way, so today actually there's a great agenda. There will be people from cloud, from actions on Google, Vikram will be talking about TensorFlow, right? And if you also might have remember Martin Omander, he was with me like 2 years ago. We were doing the GDG's North America. He's gonna also speak about Google Cloud today, but because he is now in Google Cloud team. And also in the agenda, you might have seen another person that has the same surname with me, because he's my husband. My husband also works at Google in the Android developer relations team, and he's going to talk about Hilt. And just in the morning, we were talking about, oh, my talk is before your talk, and he told me, oh, I'm going to tell my slides will be better than Nilay. So I don't know. I hope you will enjoy my slides, but I hope you will enjoy his slides as well. So I still don't see my slides on the screen, but can I start? I will have to share my screen. Okay, I'm sorry. You see, I'm still not good at these online tools. I'm so sorry. Okay, I'll do it now. All right. Can you see it now? Yay, finally. Okay, I made it. Okay, it is working now. All right. Hi, everyone. So what is Flutter? So what is Flutter? This is what I'm going to talk to you about today. So Flutter is the new UI toolkit from Google to build native applications for iOS, Android, web, and desktop from one single code base. And so why Google actually brought such a product like Flutter, right? There is also Android native development, and this is also from Google. So, but you might have had different needs, right? For example, if you look at the mobile application development processes a few years back, there were two options. One is you could either build a native application for Android and native application for iOS, and you would build very beautiful, very high quality applications, because those applications are specifically built for those platforms. You will be able to use all the system integration, all the native APIs, all the native look and feel, so you can build great applications. But the downside of building those applications would be, so you had to build two different applications for each platform, right? You're going to build the Android application using Kotlin or Java, and if you want your app to work on iOS, you will need to build another application for iOS using Swift, another programming language. And if you need web and desktop applications, these are different stories. You will still have to build those applications differently, which means that you will need different teams, different developers, different backgrounds, and also let's say that, oh, I want a change on my Android application. application. Now you need to make sure that, oh, you need the same feature on the iOS application or whatever platform you have. So different releases, different release schedules. Most of the time there are no collaboration between teams. So like this is a lot of cost. Yes, you can still build applications, but this is gonna cost you a bit more. Or again, in the past, if you don't want to spend too much effort or money, you could still build cross-platform applications. There were things like PhoneGap, right? You would build only one application, and your application will work on both iOS and Android devices, which is great. This is fast development, less cost, but the problem with that, those applications are actually not native applications. Those are web applications put in the native shell. So your application is actually a web application working in that native thing. This is why you may not be able to use every functionality and every power of the device that you are giving to you. So someone made this meme on the internet just for this, and I just stole it and put it here. So you would either want to build a native application like on the left, you can build a beautiful castle, but the effort you have to give to build that is too much. Or you may not want to spend that much effort and you would build fast application, but the result might not be what you want to do, right? And this is why Flutter comes. Flutter says you will be able to build native applications with high performance and high quality, and then your applications will work on each platform, and you're gonna write this in just one single code base. This is what Flutter offers to you. And with that, for example, you will be able to release all the features at the same time, all the brandings, and all your apps will be on the same capabilities. So which means that you will be treating each platform equally. So it is not like, oh, Android or iOS because we have that talent. So if this is what you need, if you want to build high quality native applications with little resources, Flutter offers to you this. You can use Flutter. And how Flutter does this, so this is about actually a bit Flutter's architecture. Flutter is actually an engine, like a game engine. The thing you see on the bottom, the light blue part, it's an engine, so it's Kia. And the part on top of that, it's the framework. And it is all written with Dart. So for example, the animations and rendering and then widgets, everything is a layer comes on top of each other on Flutter. And for example, there are material widgets if you want to build UIs for Android, or there are Cupertino widgets when you are building UIs for iOS, and everything is a layer on top of each other. This is why if you want to make a structural change while you are building your application, you don't have to delete everything and start from scratch. You could just go to that layer and do those changes. And this is where Flutter brings you productivity. And when we're talking about Flutter to the developers, to you, to like the companies that are using Flutter, we are talking about these 4 features. So Flutter is beautiful, fast, productive, and open. So let's look at that. So Flutter allows you to build beautiful user interfaces because Flutter allows you to control every pixel on the screen. So Flutter is a UI toolkit, right? And everything is painted, every pixel is painted on the devices. This is why your application and your designs will work on every different platform easily. And you will never have to say no to the designers when you are building nice designs, right? Because what usually happens is that designers build their nice designs and branding for your application, and they come to developers, they come to you and they say, hey, okay, now you have to implement this. But with Flutter, you don't have to do this. You don't have to say no. You don't have to deal with those things that you don't like too much. And Flutter has a lot of ready-to-use widgets to build these very nice user interfaces. You can use those ready-to-use widgets and build very nice UIs. Or if you want to customize them, you can easily customize those widgets and create your brand and bring your brand into life. There are a lot of Flutter applications on the iOS store and that got design awards. You can see, for example, Reflectly is one of them. If you go to iOS store and find the Reflectly app, you can see how beautiful designs they were able to create with Flutter. And Flutter is fast because Flutter directly compiles to the native code. This is why the app uses the all power of the device, and it works minimum 60 FPS, and you can build animations and like deep platform integrations, and you can create natural look and feel very easily. So if you see this application on the screen, on the right side of the screen, so there's an image, there's a text, and everything is coming on top of each other, and everything works very smoothly. And this is very easy to build those fast applications with Flutter. And Flutter allows you to be productive. All right. Flutter allows you to be productive because there are a lot of developer-friendly features that Flutter is offering to you. For example, hot reload is one of them. So the animation, the image you see on the screen is that. So when you want to make any change on the UIs, whatever you do you did on the code, you will see immediately on the screen. So it will take only a few seconds, and this is called a hot reload. And usually when you make a change, like when you are building another application with another technologies, when you do change, to see that on the emulator, you will have to rebuild the app, and then you have to wait a few minutes, right? But with Flutter, with hot reload, you don't have to wait for that. And of course, single code base gives a lot of productivity to your application and to your teams, because you don't have to deal with different projects, different release schedules, different change schedules, and everything. So it gives a lot of productivity, and it improves developer experience, because it is like we are a team and we are in this together. It's not that, oh, okay, there's an Android team we have to think about, there's an iOS team we have to think about, and it's a lot of collaboration working together with the developers. And most of the time, it is like when you talk to the business people or marketing people, they don't know that there are two different Android app and iOS app, right? For them, there are some goals, some needs that you want them to develop. But most of the time, those different needs, you have to do some compromises over one platform to another, right? And with Flutter, you don't have to do that, because you are building just one code and then releasing it to different platforms. And it is of course helping you to reduce the time to market, so you can do shorter cycles and very fast time to market cycles. There are teams at Google, they built their applications with Flutter again, and what they told us is that they were 3 times more faster. So it is a huge game, right? It's a huge win, 3 times faster building applications with Flutter. And of course, actually, Flutter is an open source project. Even though Flutter is built at Google, we have a lot of external contributors that are contributing the Flutter SDK itself, documentation, building packages. So every integration on Flutter, to make an integration on the Flutter, you have to use packages, right? For example, let's say that you're going to put a machine learning into your app, and you use packages for that. And most of the packages right now are written by the external companies or developers. So this is good. There's a great ecosystem outside of Flutter, which means that there are a lot of features that are added by the other people, which we cannot think them at Google, right? Because we have limited resources, we cannot think about all the use cases. But people outside, they use Flutter, and everyone has different needs, and everyone is bringing that need to Flutter by contributing to SDK or packages. Right now, there are over 1,000 packages on the pub.dev, and most of them are written by the external people. And of course, there are a lot of GitHub stars on Flutter. And of course, it's not like star number is not the biggest thing to show a success of the Flutter product, but it is that there are a lot of people that really care about Flutter, and they show up and they are there. And right now, there are so many, just 5,000 applications in Play Store and Apple Store in the last few months. So it is huge. There are a lot of new developers and companies adopting Flutter as well. And it is open source. Whoever wants to contribute to Flutter, they are welcome to contribute. And Flutter is actually used by, right now, a lot of companies, including Google. So this is the nice thing. So many applications in Google are rewritten by Flutter. Google also needs and likes Flutter a lot. But other than that, like Tencent, Capital One, Hamilton, Alibaba, they are using Flutter for their application. And I don't know if you know, but Google services are not working in China. So this is why China, Alibaba has limited services and things. So they have built their own version of Flutter just to be able to use the Flutter there for their applications. This is how much they like Flutter. So those companies, when they start building with Flutter, the feedback is they really like Flutter. And for example, Alibaba application built there, and Google AdWords, right? Google makes money from Google Ads, right? Google built the Google AdWords application for both external customer application and internal team application with Flutter again. And there are other applications built with Flutter. If you go to Flutter showcase page on website, you will see all the nice applications built with Flutter. And Hamilton, right? We are all in US and we like Hamilton so much, the musical. Even if you might not like the application, the musical itself is very nice. So Hamilton musical applications is also built with Flutter, and it was the first application we actually announced to Flutter publicly. And let's talk about animations, right? The market is so competitive. When you're building app, you want your user to like your application, use your application. This is why you use animations and then to nice user interactions in your application. And to add animation to your Flutter app is very easy because animations is also a library in Flutter. It is just a few lines of code and you will be able to animate your application. So if there is also some external tools that are built to work with Flutter. For example, Rive app. They have a tool that you can create animations. For example, let's say that you're going to create a cartoon, right? You can play with, you can move its head or legs and everything. You can build those animations. And Rive made special integrations for Flutter. So you can build animations in Rive and put your applications very easily with a few lines of code. And if you want to see how the animations work on Flutter, there are some example applications. I put their names. You can go to Play Store and check out those applications and see how animations actually work on Flutter and how powerful they are. And of course, they're so powerful because Flutter is really using all power of the device. This is why when you're putting those animations into your app, they work very smooth and very powerful, and it gives you very powerful. It gives a very powerful look into your application. And Flutter works with so many popular tools. So as a programming language, you will use Dart. So Dart is a programming language from Google. It is both used to build Flutter, but also when you're building Flutter applications, you will be using Dart programming language. And you can use as an IDE Android Studio, IntelliJ, or VS Code. If you want to do Firebase integrations, they are so easy. There are so many APIs that you can use easily Firebase into your application. And also material design. There are a lot of material design components and widgets in Flutter you can use. And also Flutter is using all the modern programming language practices. It's like Redux, right? State management or declarative UI. When you're building Flutter applications, you will be actually practicing a lot of those new modern programming language approaches. And of course, Flutter is really one of the key components of Google developer family as a part of Google Cloud, Material Design, Firebase. When you want to build your application, you can use all those technologies in this family together very easily because Flutter really allows you to use those other Google technologies very easily. So let's say that you like Flutter a lot and then you have decided to use Flutter. What are the ways? So let's say that you have a new idea or you have a new business and you need a mobile application. You can just go and start a new applications from scratch with Flutter. Or you don't have to build the entire app, but you just need a quick prototype. you can build a prototype with Flutter and see how it works. Or let's say that you have an Android app and you also need an iOS app. So instead of writing another iOS app, you can build the Flutter applications and have it work on both iOS and Android. Or if you have an Android application, you can use Flutter in your existing Android applications by adding new Flutter pages. There is a new there's a team in the Flutter team. They are working so hard about that. And how you can start with Flutter? So the official documentation, I would recommend they would be the best and easier way. If you just go to flutter.dev/docs, you will see all the steps that will help you to start with Flutter. So once you do those steps, you will see a emulator open like in this screen, and it will actually open you an example application. It's a counter application. So on that app, there's a button, and then there's a counter that increments when you push the button. And on the left, you will see all the code to run this application. So for example, if you run Flutter create from your command line, this is what you will see, an emulator and the code. And so this is also this seems like a very simple and very boring application, but this is actually a lot of information to get you started with Flutter, to show how the Flutter app structure and how it works. And we also have YouTube channels that will help you to learn a lot of features of Flutter. So this is one of the shows we do on the Flutter YouTube channel, Boring Show. So when we are doing demos, how it works, right? Everything works very perfectly. There are no bugs. There is no crash. So everything works very smoothly. But in real life, when we are actually doing the code, it doesn't work like that, right? There are bugs. We have to compile. There are things we don't find, and then we go to Stack Overflow or Google and search and copy and paste. So it doesn't work. Everything doesn't work like we saw on the demos. So this Boring Show is exactly showing this. It is a 1 hour long show. 2 of my team members, they just sit on the laptop and then build an application and build a new feature in the Flutter application. They debug things crash, they go to Google, they Google things, and then they put the code. This is exactly how we are developing applications in the real world. This is why this is actually helping with a lot of imposter syndrome. So I really recommend you to watch this show to see how Flutter is being used in this show. And if you don't like very, very long videos, there are also shorter videos like Widget of the Week. Every week we release a new video telling about what the widget does and how you can use it. Also, there is Dartpad. This is an free and open source service, and this will help you to learn about the Dart language and libraries. So what you'll do is you can write the code. You don't have to install anything. Everything works on the browser, and you can practice and you can try and see how things work on Dart and Flutter. But if you say that, no, actually, I like CodePen, CodePen also does the same stuff, and I want to try Flutter on CodePen, this is actually possible. They wrote a new editor called Flutter Editor, and if you're used to CodePen and if you want to practice on that, you can just go to Flutter Editor and try this thing on CodePen. So, addition to all of those content that our team is creating, we actually have a lot of community members that are creating a lot of videos and tutorials and everything. So this is one of them. I just put a screenshot from Andrea's YouTube channel. But if you go to YouTube or Udemy or Udacity, you will see a lot of great courses created by the community. And if you need other languages, there are also a lot of people created resources from in their local languages. And if you want to talk to other developers and understand how they are doing, or want to follow what is going on in the Flutter world, there are a lot of channels that you can join. If you go to flutter.dev/community, you will see how you can join each channel on Gitter, on GitHub, on Slack, on Stack Overflow, and you can talk to other Flutter developers all around the world. And yes, we have a lot of Flutter meetups all around the world, like how we have GDG Silicon Valley here. There are so many Flutter meetups. These are very important because, sometimes when you're doing things, you need to talk to other people, or you need to ask things to other people. And those local meetups are exactly for this. And a lot of awesome community members, they created those meetup groups so you can actually meet other people locally. When things were different, we were meeting actually in person, but now everything is online. You can either join their online talks, or once they start running on in-person meetups, you can also go to in-person meetups. And if you're not here, if you're in another country, and if you want to speak to other developers in your local language, this is also possible through those local meetups. And we have a group called Flutterista for women and non-binary folks. This is an awesome group. We come together every month. We talk and we learn Flutter together. We build the application. This is a really big support group and learning group. So if you want to join this group, you can just send an email to flutteristas@gmail.com, and they will add you to their Slack channel. So what I want to say here is that, Flutter is a really great product, very powerful product that will allow you to do really beautiful things. But also there's a huge ecosystem outside of Flutter that are doing a lot of things for Flutter. And this is not easy, right? It is not possible if we go and ask people to do things. We won't be able to have all of this. So those people are really liking Flutter and really believe in Flutter. This is why they are doing so many stuff for Flutter. So if you're interested in Flutter, join one of those things, or just go and find a course, or go to official documentation and start your Flutter journey. Hope you will like Flutter. And this is all I want to say today about Flutter. Thank you so much for listening to me. Vikram, I can't hear you. Yes.
All right. Awesome. Thank you so much. Thank you so much for this, Nilay. This was a fantastic presentation. We are all still learning how to adjust to this totally remote environment of doing presentations. We got multiple questions into the chat, and I think you answered most of them already in the slides. That was a very good coverage.
Awesome.
But there was one that I actually wanted to ask, which was not answered in the slides.
Okay.
Are there any certifications for Flutter? And if so, how do people get started on those?
Okay, we don't have official Flutter certifications. I don't know, if people really like to do that, we can consider to do that, but we don't really have those things. If you want to learn Flutter, just go and just join one of those channels and talk to us. We are very supportive to the community and to you if you need anything from us.
Awesome. Sadly no certificate, but we'll do it soon, hopefully.
Yeah.
Thank you so much. Thank you so much, Nilay. Thank you for joining us. We'll get started with next talk in a minute.
All right. Thank you so much. Have a great day.
You too. Bye.
Bye.
All right. So next up, we have dad of Jerry, Michael Solati. Michael is a developer programs engineer at Google. He's focused on web and Chrome. He has been writing code for 5 years and found his love in Angular, Firebase, progressive web apps, and the wooed ways of the web. Michael has also spoken at various meetups and conferences, including Angular NYC, JSConf in China, and the United Nations. Michael also has a side business. Michael as a service product? I think that's what it is. Feel free to ask him more about it. All yours, Michael.
Okay, I think I can be heard, right? Okay.
Yep, we can hear you. You will have to share your screen and then get started.
Yes. Give me a second. Okay, I believe you guys should be able to see my screen. Unfortunately, I can't see anything because right now I only have one monitor working, so we're just going to be working from here. As mentioned before, my name is Michael. I am primarily a web developer, and I'm a developer program engineer at Google. I specifically work on a website that you may or may not have experience before. It's called web.dev, or it is web.dev, but it's kind of like a one-stop shop for a lot of resources, and it's a really good knowledge base for things that you might be interested in as a web developer. In fact, if you ever use the Chrome Dev Tools and you like run an audit or do like in Lighthouse or something like that, and it gives you advice or recommendations on things that you can improve and how to make your web applications better, it actually links to web.dev. So that's the predominantly the site that I'm working on at Google. Besides that, I love the web. I started as a Meteor developer, then I went to Angular, but outside of my experience as a developer, I grew up on the web. I remember what things were like in the 90s, the 2000s, and now in our modern web environment. And to be honest, I love it. It's compelling, it's exciting, and we have these incredible tools to make these amazing, compelling experiences for other people. The mass thing is not Michael as a service. It is a memes as a service. So if you want to order memes via postcard, you can go to memogram.com. And I will say that I have made a lot of mistakes. So I say this only because I am hoping that through the course of this talk, you guys can pick up on some of the mistakes I've made. That way you guys don't have to make those same mistakes and suffer the same pain points I've had. Simple question then, what exactly is a PWA? The answer is not that. That is not what a PWA should be looking like. PWAs are supposed to kind of fit under these 4 different things. And I would say that you could best imagine them as web applications that have amazing experiences. And that's because they're fast. They're going to respond quickly, whether that's loading or responding to user interactions. They're integrated. They show up on a user's home screen, and they have access to sensors and can handle things like push notifications, things that users kind of expect from native applications on their devices. They're reliable because they load instantly, and they never show the dinosaur, no matter how fun of a little thing it is. And I keep a couple of these on my desk. And finally, they're engaging. They feel like a natural app on the device with these immersive user experiences. So I used to make a joke because I really, really like the Chappelle Show, but I can't really, I couldn't make that segue work. So I'm just going to put this GIF here from Chappelle Show. I will leave it to you guys to make a joke out of this, and I'm just going to move on from there. So why PWAs? Well, users actually spend most of their time in native applications rather than websites. And that's because they get this idea or this feeling that native applications are more predictable. They're available on the home screen, so they kind of have a user's attention and can pull users back into them. And they handle push notifications, which again is this part of this native experience that re-immerses users into native applications. Oh, rewinding too much. Sorry. And space on users' home screen is extremely valuable. Roughly 78% of the time a user spends on their phone is in their 3 favorite applications. So what you're really asking for to exist on a home screen or have a user use your web application or native application on their devices, you're asking for a commitment of time and space. On average, when a new user installs not really any new apps on their device, it's tough to get that. But they're more likely to visit a website, at least if it's going to be for a short, brief experience. Building a high-quality PWA will end up having incredible benefits for you as a developer, and it makes it easy to delight your users and grow engagement and increase conversion. PWAs are essentially web applications that provide these near-native experiences on mobile devices. When the criteria for a PWA are met, browsers like Chrome will actually prompt users to add the PWA to the user's home screen. With things like the service worker, you can actually send less data in order for your application to work, and you can cache data so it can continue to work after the first time these assets have loaded. You have access to things like push notifications, which allow you to increase engagement. This allows users to get updates as well as re-engage them into your application. And when users are typically adverse to installing new applications from the Play Store or the App Store, and rather might visit a website for a quick experience, a lower barrier to entry like a website might be all you need in order to be a citizen of their home screen. Native applications start quickly, they work in the background, and they work offline. They have access to all these sensors, but the problem is you end up needing to develop, like Nilay mentioned, you need to end up developing different versions of the application for different platforms. But web applications end up having this great reach because the web itself can be thought of as a platform. So you can end up having just one web application or one site that will work on every platform. It can be safe because we have tons of safe standards on the web when it comes to building our applications. But we need to introduce a lot of the features that native applications have to the web. So I actually want to show this little clip. It is from a, hold on, here we go. So this is just me opening up the Twitter application that I have installed on my phone. I'm scrolling through it, having a blast of a time, and I'm getting ready to write a tweet. And then I go to attach an image, and I pop open the camera. I take a picture of something on my desktop, and I'm able to attach that image to the tweet. And I bring this up because I think this is a really, really good experience as to what a PWA can be like. I use the Twitter PWA more often than not, just because it ends up providing virtually all the complete same experience that the Twitter native application has, but for a fraction of the size. And that fraction of the size honestly took me a while to realize. For a while, I used to have both apps installed on my phone, the progressive web application and the native application. And when I looked at the apps installed on my phone, like the app list, I was looking at the size of both of them. I see 250, 250. I'm like, oh, they're roughly the same. That's really, really weird. Until I stopped for a second because like that didn't really make sense why they were both like how much space they were taking. And I realized that the native application was taking 250 megabytes on my phone versus the PWA was taking 250 kilobytes on my phone. That was a massive, massive difference of space that the native application was taking on my phone. And as a result of that, I opted to ditch the native application and go complete PWA for my Twitter experience. So let's talk about a PWA that we have, that I have now that I created for this. It's just a movie that's designed to showcase popular movies. It's fairly simple of an application. And if you want, you can actually click into a movie to view more details about the movie. It kind of looks like a mobile application or maybe a tablet app because I'm following these material design guidelines, as well as I'm doing a few performance bits under the hood because it's an Angular application. I wanted to try to optimize it a little bit. But it's right now, that's how the web app is. So the question is, can we really consider it to be a progressive web application? And there's a tool that we can use to check this. So we can run this website through a tool called Lighthouse. And right now I am actually just running Lighthouse, and it's going to be testing the web application. This ended up being the end result of when I ran the test, where there's sorry about that. Getting used to a new mouse that has a scroll wheel, and I'm accidentally like touching it, and I'm like scrolling back. Okay, so here we go. So there's these three different categories that Lighthouse has: the fast and reliable, installable, and PWA optimized. And in a lot of these areas, I'm like missing marks or points of the application. So in a lot of ways, we could say, no, this isn't really a good PWA. First reason why is that when the application doesn't respond with the status code 200 when offline. Basically, what that means is when the device is disconnected from the internet or has poor network connectivity, nothing really loads. If you're building a PWA, you can actually use a tool called the service worker, which will allow you to cache assets and resources that are required for your website to work offline. And because we're not doing that right now, it's failing that test. The next bit is that the service worker, that the application doesn't register the service worker that controls how the page will work as a PWA. Like I mentioned, the service worker is the technology that enables our application to use a lot of these features that we relate to PWAs, such as offline support, the ability to add to the home screen, as well as handling push notifications. There's a file called the web app manifest, which this application doesn't have. And if it did have it, it would allow the user to install the application as a PWA into a user home screen, because it actually dictates things like what are the icons on a user's home screen, what theme colors it should have. So like when you pop open the application, what color the status bar should be, the splash screen before it loads. So that web app manifest dictates the splash screen. There's a few other things like the address bar theme color. So like Chrome, if you used to use Chrome on mobile, the status or the address bar or the Omnibox bar would actually change the color to kind of match the theme of the application. And finally, it doesn't provide a fallback when JavaScript is not available. This one, I think, is actually really important and really underrated. I bring this up because I used to work in a web shop where we built websites for clients. And there was this one client we were working on the application, and for the longest time, no matter what we did, the client was able to view and manage the application on their desktop, but when they were on their mobile device, it just did not load. And we couldn't really figure out why. The client had an iPhone, and we were all pretty much Android users. So our manager or boss decided to get us all brand new iPod Touches because we are a startup. We're not affording iPhones. But we got the iPod Touches because we kind of wanted to figure out why isn't this website loading on iOS? It loaded on iOS for us, so we still didn't figure out why. Until one time the client actually came in and we were looking on their actual iPhone to figure out why it's not loading, trying to debug it on the device. And it turns out that they kept JavaScript disabled on their phone, on their iPhone. They didn't know that was a problem. They didn't understand that that was the reason why the website wasn't loading. And we had no idea as to why the website wasn't loading. But what ended up happening is that the client, which if this was a user, they would have just had an experience thinking like, oh, this site doesn't work. There's no explanation why it doesn't work. It just doesn't work. So I would recommend having some sort of fallback for when JavaScript is not enabled to inform the user like, hey, this experience may be subpar or may not work altogether because you have JavaScript disabled. You can handle this with like doing server-side rendering, where instead of depending on the client to generate the JavaScript, the client taking the JavaScript to generate the pages, you can generate the page on the server. Or there's actually a tag called noScript, which will only be rendered if JavaScript is disabled. So I throw those things out there just because that is a personal experience that like really sucked, but I think is really important to take into consideration. So as it stands right now, this application, it's not fast, it's not integrated, it's not reliable, and it's not engaging. I mentioned before that I was going to run the website through a tool called Lighthouse. If you don't know what it is, it's an open source automated tool for improving the quality of web pages. You can run it against any web page, whether it's a public page or a page that requires authentication, and it has audits for things like performance, accessibility, SEO, and whether the application is like a PWA. Now, Lighthouse is actually built into Chrome, so you can use it in the dev tools. You can actually also install it as an extension that's available on Chrome and Firefox. And it's also available as a NPM module. So you can either install it as a global dependency and just run it from the command line, or you can include it in your code base as like part of your testing suite. So let's take this application and start to try to make it better. And the first way we can do that is making the application be more reliable. Being more reliable means that there shouldn't be any more surprises. Again, I used to try to make jokes. I've given up on making the jokes, but here's a Smash Brothers reference. So being reliable. When launched from a user's home screen, the service worker is what enables a PWA to load instantly, regardless of the network state. Our service worker is written in JavaScript, and I would best describe it like a client-side proxy that puts you in control of the device's cache and how you're going to respond to network requests. You could pre-cache key resources. That way you can eliminate the dependence of the network, and that would ensure an instant and reliable experience for your users. This is actually an example I think we had on the Google developers website. I might be mistaken, but this is an example of how you could implement a service worker with a caching first strategy, or cache first strategy, which is ideal if you're trying to build an offline first experience. So how you might end up handling a bunch of requests is that when a page makes a request for a resource, it'll go to the service worker, and the service worker will then check the cache if the resource being requested exists in the cache. If it exists in the cache, it'll be returned to the page without having to make a network call. If it doesn't exist in the cache, then it'll make the call to the network. So you'll request the resource from the network, and that resource will be returned to the page. Kind of like a regular web experience for most applications. But what the service worker will also do when it makes the request to the network is that it will cache that resource for future requests. So that way, the next time the page makes a request for that same resource, instead of having to be dependent on the network and make that network request, it can just pull it from the cache. And introducing a service worker into your website can be super, super easy. If you're an Angular developer, there's a schematic that you can install, and it'll apply a bunch of different things that you are required for the service worker and PWA support. The command is just ng-add @Angular PWA. It adds a bunch of files. It enables the service worker on prod builds of your application. So simple way to do that. If you're a React developer, well, starting in 2017, the Create React app has actually included service worker and PWA support from the get-go. So as soon as you create your React application with the Create React app, you have service worker PWA support. And that's also true of the Vue CLI starting from 2017. So when you go to create your application, so Vue Create app, you can just manually select some features, and all you want to do is enable the PWA support. The rest of it you can continue to do with whatever, and that will just end up working the way you need it to. Okay. So taking Vue, for example, though, you can actually modify aspects of the service worker. And that's actually really important, because what a lot of these tools that like Angular, React, and Vue have, they kind of create these default default service worker things that require you to customize them, because they can't necessarily expect everything you need to be cached or how you want to handle caching. And a lot of these tools are actually built on top of something called Workbox. So Workbox is it's a library that we actually also build at Google, and it bakes in a set of these best practices and removes a bunch of boilerplate that every developer writes when they end up having to write a service worker. It can handle things like pre-caching resources, runtime caching, handling different caching strategies, request routing, handling background sync, debugging your service worker, and more. It's available on NPM. And I would definitely say, if you're interested in learning more, there's a great article on Workbox that's on web.dev. It's written by a member of the Google's web developer relations team who actually works on Workbox. So I would recommend, if you want, check out that article. It's available at web.dev/Workbox. But with a service worker in place, instantly our application is reliable, because we can easily have the application work offline. So we're not dependent on a network in order for our application to work. And it's kind of a bit faster, because after the first request for some of these resources, we can cache these resources for them to work the next time without having to be dependent on the network. But fast-ish, we can make this faster. Back. Faster is important, because the average load time for most mobile websites is roughly 20 seconds on a 3G connection. And that's a lot of time. And that's not necessarily the best when half of users will actually abandon a website if it takes longer than 3 seconds to load. And once it's loaded, it's expected to be fast. You don't want these janky scrolling experiences or things respond to a user slowly. People expect things to load quickly. Maybe on average, users will expect a website to load within roughly 2 seconds. It's that waiting for sites to load is what people hate the most. And luckily with our service worker configured in the previous section, we've addressed a lot of these concerns, but we can still optimize that initial load, parse, compute, and rendering of our application. And this ties into another consideration or a massive concern, and that's the cost of the JavaScript that we're writing. So I'm actually stealing this slide from a friend, an amazing propagandist for the web who works on the Chrome team, Adi Osmani. Keep in mind, if we want to be fast at JavaScript, we have to download it, parse it, compile it, and execute it quickly. But not all bytes weigh the same. A 200 kilobyte script has a very different set of costs compared to a 200 kilobyte JPEG image. And that's outside of the raw network transmission times for both sets of bytes. They might take the same amount of time to download, but when it comes to processing them, we're dealing with a very different set of costs. A JPEG image may need to be decoded, rasterized, and painted onto the screen, versus a JavaScript bundle that needs to be downloaded, parsed, compiled, executed. And then there's actually a number of additional steps that a JavaScript engine needs to complete. So I raise this because the cost of these files aren't necessarily the same. It's important to remember that JavaScript being sent down the wire has to be computed and rendered out for our PWAs or single-page applications. We can, however, take this burden off of the user and onto our server with server-side rendering. So luckily, all major frameworks provide decent support and for server-side rendering. And as a front-end developer who doesn't like to write these full back-end solutions, it's, I think, fairly easy to implement. And there's non-first-party solutions as well that streamline the daunting task of configuring your own server-side rendering environments. In the React world, you have Next.js, and in the Vue world, you have Nuxt.js. But if you aren't using any specific framework, you can always use Puppeteer. Puppeteer is a node library which provides this high-level API access and control to Chrome over the DevTools protocol. Puppeteer runs headless by default, but can be configured to run in non-headless environments as well. And you can actually do a lot with Puppeteer. You can generate screenshots of pages or PDFs. You can run tests inside of Chrome. You can crawl single-page applications. And most importantly for this is that you can generate pre-rendered content. Because Puppeteer, what we'll end up doing is just load the page. You can wait for the page to fully load and for the JavaScript to be executed, grab the HTML executed, and return that. Like Workbox, you can install Puppeteer via NPM. And it's actually really simple to implement. This is all that's really required, this code here, in order to run Puppeteer as a server-side rendering engine. So what ends up happening is when a GET request is made, that what the Express server will do is it'll get the information as to where you're going to. It'll launch Puppeteer to that page. And then it'll wait for the network to idle. Once the network is idled, it'll grab the HTML content from the page, it'll close the browser, and it'll send the HTML to the client. So with that, now our application is reliable and it is fast. The next thing we want to do, though, is have this application feel engaging and interactive. We want it to feel like a natural app on a user's device with this immersive user experience. And PWAs are installable. They live on a user's home screen without the need for an app store, and they can offer these immersive full-screen experiences with the help of the web app manifest. You can actually re-engage users with push notifications as well. But the web app manifest is what allows you to control how your application appears and how it's launched on a user's device. And you can specify things like home screen icons, what page to load when they pop open the application, screen orientation if you want to lock them into portrait, landscape, or allow them to rotate. And the tool is actually really simple to use. So I'm actually going to try to here. So this is just a sample of this web app manifest generation. So I can just give my application name, and the short name would be kind of like what you would see if the full name is too long to appear on the application, on the home screen. The theme color could just be whatever color I want the status bar to be. So it's I'll just do some random color. The background color is the splash screen. So when a user pops open the application, the first thing you kind of see is the icon before the application loads in. That just picks what color that is. You can choose how you want the application to show. So it'll be a full screen application. You won't see anything with the browser. I'll allow the user to rotate it any way I want. And my favorite part about these sorts of tools is that you can actually pick an icon. So it'll take an app icon that I have here. And when I click submit, it'll actually resize that icon for a slew of different screen sizes. So that will end up downloading a file. So here is a manifest, which I don't know if it'll open. Here we go. It generates a manifest file with all the settings I have sent with references to all these images. And if I check out the images, I actually have the icon resized at all these different resolutions. So I'll just close that real quick. I share that because it is a super easy and simple tool to use if you want. And like, long story short, I would say this is like the easiest thing to do if you want to get your application to behave more like a PWA. So check out this URL. You could dump this into your application. Super, super easy. In fact, all you really need to do is go to your like index HTML file and just add these two lines. One is a reference to the manifest file, and the theme color is another thing you can do in order to provide that more native experience. So with that, the application is fast, integrated, reliable, and engaging. And there's a lot of other APIs that you have access to as a web developer working in a browser environment. Some of my favorites here are like these quick start shortcuts that's actually supported in Chrome 84 on Android, as well as Chrome 85 and Edge 85, where kind of like your native applications, if you press and hold them on your device, you can get shortcuts into specific tasks. You can do that in a PWA as well now. And it's kind of simple to implement. In the manifest file, you can just create shortcuts where you reference the icon that you want to use for it and what URL to pop open to. So there's a bunch of different things for that PWAs are capable of doing. So these are just a few different things that I would recommend taking a look at. There's app shortcuts, which is what I just mentioned, the badging API, which is used for notifications, and the TWA, something I actually didn't mention. TWAs are called Trusted Web Activities, and kind of like PhoneGap or Cordova, it'll allow you to wrap your PWA and launch it to the Play Store. And that's actually something you could do. You could take what PWA you've built and put it into the Play Store within like a minute, sorry, not a minute, within an hour. So if you want to get presence on the Play Store, you can do that as well really, really easily. So with all these things implemented, like the service worker, server-side rendering, and the web app manifest, I wanted to actually run the Lighthouse tests against the application as well. So here I am running Lighthouse. And all of a sudden, it's all green here. So it hits all the things that are required for it to be a PWA. And if you want to check it out, you can check out the PWA that I built. It's at pwa.otta.dev. In the top right corner, there's a GitHub icon. I believe if you click that, it'll take you to the GitHub repo. And if you want to look at these slides, it's available at bit.ly/building PWAs. Casing is important, so make sure the uppercase B, uppercase PWA. Finally, though, I would like to say that however much I love the Chromosaur or the Dinosaur, I would like it to see it go the way of the regular dinosaur, which is extinct. Anyway, my name is Michael. I'm available on all these different platforms with just my name. I am probably over time, so I apologize for that. I'm going to close this out, and I don't know if there are actual time for questions. Vikram, I leave it to you to tell me.
We actually do have a lot of time. So we will ask you a lot of questions. Let's see. Actually, like most of the folks, like in comments, if you have questions, please feel free to ask them, and we will ask them right here onto the video. But as people are getting started on that, let me start with the first one. What would you say to someone who is trying to decide between PWA and Flutter? I had to ask that.
No, it's a good question. I would almost always say PWA first. I guess I should be tactful about discussing other parts of Google. I think a Flutter application will provide a better experience than a native application. Than a web application, without a doubt. But I think a PWA is the lowest barrier to entry. It gets you on every platform, not just Android or iOS. You're also on like Windows, Mac, because you can install PWAs onto a user's device. And while Flutter, I know, has the capability of exporting into a web application, it is very, very heavy, at least as of right now. So I don't think Flutter development makes for a good web experience, but I think a web experience could make for a good native experience, especially if you need a prototyping to get out the door. And here's the thing, even if you deploy a native application, it's still going to be bigger in file size than a PWA. And if you're going to be talking about these second or third world countries where network connectivity is not as reliable, a PWA still ends up being a better solution than a Flutter application. But if you need cross-platform support and you're not as concerned with the cost of like file size and stuff like that, then yeah, Flutter definitely is a great solution.
Yeah, I'm definitely on the team web. As much as I love Android and iOS applications and like Flutter for cross-device applications, I like the web has the power that none of the other platforms really do have, which is, of course, like use once, close the tab, and you are done. Like it's totally gone from your app. You don't really have space. You don't have to worry about all those things. Yeah, awesome. What would be a good resource that you would recommend to folks if they want to learn more about this and like keep continuing on this path?
Yeah, so web.dev does have a bunch of resources for PWAs. Like I think if you go to, I'm actually going to check my computer right now, make sure I give you the right URL. I think it's just web.dev. So if you go to web.dev/PWA, it'll take you to this entire section about PWAs and like different things you can do, and it'll include code labs as well. I would say that is a great resource to go from. As far as follow-up resources, I don't know what the best ones are. I've kind of I would say just starting at web.dev/PWA is the best place to get started from.
Nice. I also like to follow Chromium developers. I think that's a Twitter handle, and they do publish videos after every Chrome release.
Yeah, actually, good point, because I probably should pitch this. Next week is the Chrome Developer Summit.
Oh, yeah.
We're going to be live streaming on YouTube, which is going to be focused on, obviously, Chrome and like the web in general. I don't remember the URL. So if you go to web.dev, I recommend that to anything. Or if you go to web.dev/PWA, there's actually a banner that will link you to the Chrome Developer Summit. So check that out. But yeah, CDS is next week, and I would say that's going to be a lot of great video content there as well.
Nice, awesome. And if you don't get your questions answered today, be sure to join in on Chrome Dev Summit, and like there will be some more folks and who can answer your questions there as well.
Yeah, there's actually going to be a bunch of us answering questions in the YouTube live stream as well. So we will be actively trying to answer questions for you guys.
Awesome. Next question that I have is there any local file support for PWAs? I think
yes.
Trying to ask. Yeah, go ahead.
No, my answer to your question is yes.
Yes.
I think I need to understand a little bit more about what you are looking for.
I think maybe the question is answered in the Twitter PWA, where you were able to select a local file and that showed up inside the app. So essentially, yes, I think. But
then yes, I would say you can get access to users' files, and I think like the input element lets you do that, like go through users' files. But there's also other things that you can do with for file storage. I think obviously there's like a web.dev article for it, but there's a file system API. I do not know the ins and outs of it, but I think that might be along the lines of what you would want to look for, though I do think it's only currently supported by Chromium-based browsers. So, but that's a lot of browsers right now. So I would say the file system API and file system access APIs might be the ones that you're interested in as well.
Nice. Yeah, take a look at that and let us know if you have more questions. Of course, you can reach out to Michael on Twitter as well. Next question that we have is, how would you integrate data privacy and security concerns, like data storage that is happening on the local PWA and any concerns with that? Should this be done on the client side or the server side? It's a long question, so take your time.
Sure. Give me a moment to think about this.
Of course.
You're going to be storing user data on your server no matter what. That's like not really a doubt. And how you decide to store that user data on the server is very, very, I can't really answer that because it depends on the industry you're in. If you're doing financial technologies or you need to develop these HIPAA compliant systems, that's a very different set of concerns that, yeah, you most likely will want to be able to encrypt data on rest. Ideally on the client, though, I am personally not as concerned with caching resources because I am trusting the user to like not just give their. I would not be as concerned on a device you can still definitely take options. Like if there's thing about showing credit card information, you could choose not to cache that network request. That way, that's always a request that needs to be made. Or you can. So you have a lot of choice as to what you're going to cache on the user's device, and I wouldn't necessarily cache things that you think could be dangerous for it to be leaked. Though I'm sorry, I'm rambling. I don't have a good answer. It really depends on the application you're building. Though.
Yeah, I also think that like web guarantees the privacy that it does generally across other websites. Like Google.com can't access the data that you have on your own personal website. So that way, those guarantees are always there. So if you are storing the data that is with your PWA, that can't be accessed by other PWAs. So with those guarantees in mind, like, yeah, you shouldn't really have to worry too much about it. If someone gets physical access to user's device, of course, like there's not much you can do in there.
And there's also issues with. Sorry, I saw one comment about the diplomacy of the answers. Yeah, I'm trying hard here. I think Chrome extensions also could be a vulnerability point, or but that's your device being compromised more than your website being compromised. And there's like cross-origin scripting, but a lot of frameworks, if you follow the guidelines, will protect you from that. So I'd say those are other things I'd put out there.
Nice. Another question that we have is, does PWA have all the native web functionalities? What would be the missing ones that you know about? I think they do, but if there's anything missing?
I'm sure there are. I'm sure there are. Notifications are handled, right? You can do notifications with the service worker. And I think Firebase actually makes it easy to do as well. I believe the Firebase JavaScript client now makes handling push notifications easy. So I would say my biggest concern with building a PWA isn't necessarily if I can handle like a lot of the features, because I'm willing to bet I could build enough features. There's enough features on web for me to be able to build my native application, my web application. For example, two APIs that I think that are available on Chrome for mobile that I think are awesome is the contacts lists, and one-time password sort of thing. I think the one-time password sort of thing is used. I forget the application. It might be Oyo or something like that. It's some Indian marketplace thing or some website.
Flipkart, I think.
Maybe it's Flipkart. I don't recall, but I think it's one of the things that because like email addresses aren't as common as phone numbers.
It's a Flipkart.
Okay.
Yeah.
What they do is when you punch in your phone number, it'll send a text message to verify your account. So that's like your one-time password. But instead of the user having to go into the text message, copy and paste it, on Android, the Chrome browser can actually detect the text message and automatically fill in that one-time password. I think that's an example of something that's native, but is also capable on the web, which I think is super, super cool. The other thing with accessing the contact list, it seems dangerous at first, but you also have to request permission to do that, just like you would a native application. But let's say if you're building something like a social network and you want to invite friends to it, your network, instead of having to like find their email address in your contacts book and copying and pasting it, just quick, immediate access to the contacts. Like these are things that are built into the web right now that you can just use that I think are super, super cool. The only thing that I would have a concern with is when it comes to computing. In the web, like when I've had to do Google Maps specific stuff and I'm dealing with marker sets like greater than 100 markers at a time, like my mobile device will end up chugging. Even my browser will end up chugging just because of how that's handled. And there are solutions like web workers, but I would say when it comes to compute heavy stuff, then you might want to shift off to native. But I don't think there's a feature that's super important that's missing.
Yeah, the only concern that I used to have earlier was the file system access, because with PWS you could only access so much of storage. But I think with the file system API that has been addressed, and if it's not, like I'm sure like you can ask those questions in public forums, and if there's something that you seem missing, you can ask more about it. Chrome Dev Summit, just a reminder, it's on December 9th and 10th, and there it will be a perfect place to ask more of these questions. This is a curveball question here. What's your favorite Chromium browser?
Chrome. I'm not making the.
Let's do why. Why Chrome?
I can sign in with my Google account. And no, I'm not making the shift to Edge because I feel like Edge is a hard. Like I do use Windows on my desktop. It sucks. Edge, and they push it so hard. I don't want that. And I think I started with Chrome just because of the sync support with Android, and I know Firefox does it as well, but I don't feel like every site works as well with Firefox, so Chromium ends up having to be what I do. My favorite Firefox browser? I don't know. Nightly. Firefox Nightly. That is my favorite Firefox browser. I prefer the darkish blue logo of the fox.
Let's do one last question. I don't actually know which one to ask. Actually, maybe you can talk a little bit more about AMP pages, or AMP itself, AMP pages.
Unfortunately, AMP is a different team that I don't spend enough time staying up to date with. I would say the goals of AMP and PWAs are kind of different. I would say very different, though a good PWA can work like AMP. I say that because if you're on an Android device, right, or you're on a Google Pixel or whatever, and you swipe to this side, you get these like recommended stories and stuff like that. And typically it'll push to AMP pages. But if your web application is performant enough, it'll also pull those pages as well. And I think it's the if it hits the categories for what are called vitals or web vitals. So if you go to web.dev/vitals, you can look more into that. But it's a set of optimization and guidelines for making these web applications have these better experiences that I think if you hit those categories, Google search will treat you like it does treat AMP pages on the Discover section. Though I think web applications and good web applications are also prioritized in Google search. I'm rambling. I don't know enough about AMP, so I'm just making it up as you go
Let's
along.
do another question actually in place of that. What would be the good what would be a good use case for PWA applications? Like, how would you decide between when to use a PWA app versus not?
I would say always build a PWA. If you're
Yeah,
gonna have a
always.
that sounds dumb. It's not. If you're gonna have a web experience, make it a good web experience.
Yeah.
Make it work on mobile. And that's it. Like, if you have a good experience that works on mobile, that could be a PWA. The requirements to hit to be a PWA, it's not a high barrier to entry. And if you're using a framework, you can easily integrate it into your build system. Obviously, to be a great PWA, there's a lot of work that can be done, but the barrier to entry is like really, really low. So if you're going to have a web experience, make it a PWA. That's it.
Yeah, just having a small offline capability like makes your application experience so much better. There's no reason not to do it. So yeah, awesome. This has been really great. I see that there are more questions which are more fun-like, but I'm sure like people can find answers to that. Unless you want to take one of those questions.
I'm just going to take one real quick because it's right in front of me. I'm going to butcher the name, so I apologize. But I think someone asked, can I access camera? Thank you. Yeah, can I access camera, gyroscope, GPS, and such in PWA like a native application? The answer is yes. To access a camera, it's not difficult. I showed the Twitter PWA that accesses files or camera. Gyroscope, yes. I don't know how to use it because I never use it. And for the GPS location, yes. You can either grab a location statically one time, or you can watch a location. Yes, you can access all of those things.
And if you need to find docs for these, I'm sure they're on web.dev.
Yeah, web.dev/PWA might have an answer for whatever it is you're looking for. I think there's an advanced topics section as well as a capabilities section, which might help answer that question.
Nice. Awesome. Thank you so much, Michael. Thank you for taking your time and giving us through this walkthrough of PWAs and answering all these questions. If anybody wants to reach out to him, he is on Twitter. And don't forget Chrome Dev Summit, December 9th and 10th. Thank you.
Bye, guys.
Bye-bye. Awesome. For our next, we have actually a break for 15 minutes. But sadly, I missed asking enough questions on Nilay's side, and we have to extend it to 30 minutes. So we'll all join back in here at 12:15. Thank you, everybody. See you soon. Hello, everybody. Welcome back from the break. Hope you had a chance to refresh yourselves, get something to drink, take a walk outside. There are so many things that you can do. You're at home. Nice. Next up, we have Jessica. She's mom of River. Jessica is a developer advocate for Google Assistant. She loves to connect with developers and explore voice user interfaces to add another dimension on how users interact with technology. Jessica is a woman in voice advocate. You will find her either spending time with River, collecting strawberries, knick-knack, or biking around town. All yours, Jessica.
Thanks. Hello. I'm hoping everyone's doing well. I believe we have there's so many DevFest and there's so many events that we do. I believe we're going to be playing a recording of my presentation. So we'll do the recording first, and then I'll be here on chat. So if you have any questions, feel free to ping me on chat. Welcome to Multiple Ways for Building for Google Assistant. I'm Jessica, and I'm a developer advocate for Google Assistant. So Google Assistant is the virtual assistant that enables conversations between you, the user, and Google to get things done. And Google Assistant is available in over 19 languages, in over 80 countries, which is fantastic. It's available on smart displays, on Android phones, iPhones, Google Homes, voice-activated speakers, and more. And you can take advantage of leverage that reach by extending the Google Assistant by creating your own actions. And you could do that by using our platform, Actions on Google. And since everyone has different needs and different resources when it comes to your own products and your own brands and your own projects, we've actually divided and organized the ways to build around the different mechanisms of resources that you might have. So let's go into each of those. And we're going to start off with content actions. And so if you already have a website, a podcast, recipe list, what you can do is you can actually optimize those efforts by extending them to Google Assistant. You can structure your websites so then Google Search could consume that data and be able to surface it to your users. You can think of the same thing with Google Assistant. And so all you have to do is just add in schema.org and structure your sites in a way that Google Assistant can also understand and consume and be able to deliver your content. And so these type of categories usually fall in the buckets of like FAQs, how-to guides, news, podcasts, and recipes. And all you have to do is just add that structured data markup to make your content available in a richer way on search, which will also apply to having all that content being delivered on Google Assistant too. So here's just an example of a podcast where they're just using RSS and being able to add in that structured data so that it could be optimized to work both for search and for the assistant. Next thing is app actions. And so app actions is a way that you could extend your Android apps. And when it comes to Android apps, there's a lot of cost when it comes to driving for app installation, as well as having users re-engage. And so to optimize for this, or at least one of the reasons why this happens, is there is a sea of icons most likely on your phone, because I know that's how my phone is too. And so what you could do is, how can we bypass that step? So then your users, makes it easier for them to not having to remember what does your app look like and being able to find it in this sea. And so with app actions, it's a way to allow Android developers to use the assistant to kind of fast forward users exactly to the spot in a way that they could use just their voice, which is great. So to highlight this, so we're going to use a fig example called S'mores. And this is a niche delivery s'mores industry, that company that we've made up. And so you can imagine some of the steps that might happen is the user would have to go and try to find the icon, and then they have to select all their options that they like. So things like the cracker, the marshmallow, pick your chocolate. How toasty do you want it to be? And how many do you want? And that's a couple of steps for the user to go through to be able to go into the order. It's a lot, it's long. But another way that you could do this is you can actually implement app actions and make this faster for your users. And what that means is your user can say naturally with their own voice that they would like to order one medium roasted chocolate marshmallow s'more, and that way that information all gets put into the your Android app, and it opens up the confirmation page right there for the user with all the parameters provided, which is fantastic. So it's a lot easier for users to use your Android apps. And of course, when it comes to ordering, it's not about just app actions. There's a couple other examples. So let's check out what Nike has done. So you can actually do where you could talk to the Nike app and just say, start a run on Nike Run Club, which is great. You can also do other things like send money using this application or order things through these other Android apps too. And all of this is possible by using built-in intents. And so these are ways that you can, as the Android developer, let Google know that you have these functionalities like order food or start an exercise. And that way it gives Google ability to kind of hook into, okay, these are the functionalities that the user can have, as well as you want to be able to provide what parameters the user will need to get from the user. And then as well as what's the fulfillment URLs, like where should this go to once I grab all these parameters too. So you could use built-in intents, and we keep adding many more as time goes by. We've also recently created 30 more, or we have over 30 built-in intents too across 6 different categories, which is great. So there's a plethora of different intents that you could potentially use with your actions. And this is just an example of an XML file using the built-in intent for order menu. And so here you could see that we're using an intent name of actions.intent.order menu item. And that's a built-in intent that we have provided. So you could use this so then users could order from your menus. And that's just an example using this built-in intents. Another thing you could do is use Android slices. And so there might be times where you want to provide your user quick inline information or an answer about something like a confirmation of an order. And so you could use Android slices to provide that information in a nice, easy way so then users could just get updates fairly quickly, which is great. And just a note, when it comes to the built-in intents and items like this, Google Assistant is handling and managing all of the NLU. And so you're not having to worry about how users might ask about this content when you're using built-in intent in Android slices. So let's move from Android to smart home. And with smart home, it's all about integrating with hardware. And so if you're interested in home automation, you could do this through our smart home integration. And this provides you a home graph. And the home graph knows the state and capabilities of all the connected devices. And so users can ask things like dim the lights a little, and it'll know what to do intelligently, which is great. And so one of the best parts is when it comes to the natural language understanding, similar to with Android and built-in intents, Google Assistant will handle all of this for you. So if somebody says make it warmer, turn on and off the lights, setting those particular parameters, like I want this temperature, it will pass that data on to you as a parameter, and you could use that as well. So here's an example of our traits and types that we have to offer. Types are the actual type of hardware. And so you can think of these like the windows, lights, fireplaces, blinds. And so these are the actual hardware elements. And then there are traits, which these are the properties or characteristics of those. And so you can have something where the lights are on or off, but then you can also have the lights be dimmable. So that might be a different status or a different trait that you might want to check as well. And we have lots of those, so please check out our docs to see the latest ones. And so let's go into how to integrate. So in order to integrate your device with Google Assistant, developers need to provide their own cloud service for users to register and manage their devices. The Smart Home Action platform then integrates with the cloud service using a series of webhooks to access and control these devices. Something that's really cool that we launched about a year ago is our local SDK, our local home SDK. And this is done through the Wi-Fi. And so devices on local networks can be discovered and controlled with local protocols, which helps reduce cloud transaction costs, which is fantastic. And finally, if you want to build new, rich experiences for your users, you would build conversational actions. And so similarly to how Smart Home is structured and the rest, the user will send a request, Google Assistant will process that. And unlike with Android and with Smart Home, where there's the built-in intents or the types and traits where they're already defined and Google's handling that natural language processing, Google Assistant will handle the text-to-speech and give you the text of the user, and then it's up to your action to process that and figure out what to send back. But your action would figure it out, send a response back to Google Assistant, and Google Assistant will deliver that to the user. But for example, if a user says yes, that's pretty straightforward. If in your interaction, the user says that, you can parse that out fairly quickly, right? But what about all the variations of yes, like, I agree, go ahead, and so much more? You'll need a tool to manage all of these variations. And so you'll need a natural language understanding, or NLU, to help process your user's information. And you do that by identifying the different intents your user may want to do, like expressing a yes intent or a no intent, or how many players are going to play a game intents. And once you've identified that, you'll need to provide training phrases for each of these intents. And that way, Google Assistant can understand and know, okay, when we're talking about the yes intent, it encapsulates all of these variations of yes, and it'll build onto more. And so now let's update that diagram. And so the back and forth conversation with your action is done this way, where the user's input gets sent. Google Assistant will process that with its NLU, send that information to your action. Then your action uses that to generate a prompt and then sends that prompt to Google Assistant, in which Google Assistant delivers that to your user. But how would you know if the user that's saying yes, where they're saying yes in the conversation? Are they saying, yes, I want to play the game, or yes, I want to drink the magic potion in the game? You can't just have these intents kind of flying around. You need to organize them somehow. And so managing the conversational model of your for your action is key to generate the appropriate prompts. And you could use Actions Builder. An Actions Builder is a web-based IDE that's fully integrated into the Actions console. You only have one window to build your actions now, which is great. And so you can design your conversation flows in a way that's visual, and it also supports and actually has improved the natural language understanding when it comes to processing your user's input. It also includes an inline editor, so you could have responses be built dynamically using a webhook as well. And so with Actions Builder, it processes the user's input and does either intent matching or slot filling when it comes to types. And so you're able to pull out the pieces of data when it comes to a user's responses. And you use like this new concept or this different concept called scenes to manage the logic. And so if an action gets started and the user says yes, the intent gets matched to the yes intent. But because it's on the start scene, it knows, oh, they're saying yes to start this game, not saying yes to drinking the potion. And then from there, it could transition you to the next scene to actually start the game, which is fantastic. And you could build prompts, of course, dynamically or statically using this tool too. And so scenes is a new concept for when it comes to action developers using our old tooling. And so let's dig into that a little bit. So scenes are these logical chunks of your conversational model. And they are the executors of your action. They do all the heavy lifting. They carry out the logic that is needed to drive the conversation forward. And so you can even think of these things, scenes, similar to scenes in a movie or a play. It's a way to modularize your action. And so you might have, again, the welcome scene asking that question, do you want to do this or do you want to do that? That has intents tethered to it. And so if a user says something, it could transition you over to the next scene. An interesting thing too is your scenes can ask and collect data using slots. And so this is a way, if your slot gets filled, a scene can transition to the next scene. Similarly, you can think of this as ordering. You have filled up, or we have all the information of, let's say you're buying a dress. We have what size that you want, cool. And then we transition you over to actually be able to purchase this or be able to do the delivery information. So you can think of it like that. And scenes are really flexible, allowing you to do some really cool things, but all scenes run in a loop. And this flexibility is great. And the execution life cycle is something that we should kind of parse into and dig a little deeper into here. So each stage inside of a scene are optional, but the flow starts with on enter. This is where you can add a prompt to the prompt queue or make a webhook call. Then conditions are checked, which are your if and else if statements that would check your session, user, or scene parameters. After that is slot filling, which will add a prompt to the next missing slot that's required. And then it's the prompt stage. And this is where the prompt queue is delivered to the user. And then once the user responds, the user's input is going to be processed, and it'll either match the slot if that was required. It'll loop back up to conditions to check if conditions are met. And if not, we'll continue that loop. And if the user's input matches the intent, then the intent handler is processed. And if there is not a transition, it'll go back to conditions and follow the loop. And if there is a transition in that intent handler, it'll transition to a different scene. Complementing our Actions Builder is our Actions SDK, which gives you a file-based representation of your action and the ability to use your local IDEs. The best part is that it works alongside our Actions Builder. This includes all the configurations, resources of your action, including support and internationalization. And so you can build using Actions Builder, then pull your project down locally, make changes, and push those changes to Actions Builder, allowing teams to work in their preferred tooling, which is great. We've also improved our simulator, which provides execution logs within the request and response data to make it easier to debug your action. And these are organized by the scene, by the interaction between the user and Google Assistant. But then you could click on that and you could see the scene data. You could see what parameters are being passed, when webhooks are being called. And we've also added a state editor to make it easier to update and debug your content by making those changes in the scene editor. So you're not having to go through the whole flow. You can connect things a little easier or make it seem like the user's already done XYZ. And that way you can go directly to where you want to test within that conversation flow. Actions Builder and Actions SDK provide the conversational components of your action, but you can add other elements to enhance your user's experience. You could use interactive canvas, so you can build rich game experiences that provide detailed visuals for your conversation. And the great thing is this is all built using a web app. So HTML, CSS, and JavaScript is all you need to be able to create a web app, and Interactive Canvas API will connect that web app with your conversation and be able to have a voice-first experience when it comes to this action, which is really fun. Another thing that you could do is add continuous match mode. And with this, it actually allows your user to be able to say kind of consistently different words or phrases. And so a great example of when you want to use this is, let's say you have a map of a kind of a country with all the different states, or a map of the world with all the different countries. What you could do is display that using interactive canvas, so you have that nice visual, and allow the user to say the country names and be able to say that rapidly. And they actually can be able to process that and go, yes, you said Australia. Yes, you said China. Yes, you said Korea. Yes, you said Mexico. And be able to process that using continuous match mode, which is great. And when it comes to, from the developer's point of view, all you need to do is provide configuration that consists of the list of the exact phrases that the user might say. So if it's the example of a world map with all the countries, you would want to list out all the countries and provide that to the action. And so the Interactive Canvas app, web app, can process that quickly for your users. Well, that was a lot that we covered today, but this was just to give you a breadth of the different ways you can build for Google Assistant. And we're really excited to be able to share all of this with you and have you build your first action. And of course, we would love to hear back about what you think about the content of this presentation. So please go to goo.gle/AOG-intro-feedback to provide feedback about this particular content here. And of course, check out all of these links for docs for building with content actions, building for app actions, building for smart home, and building your own conversational actions. And if you're anything like me, I know I like to learn by actually having somebody walk me through. So feel free to check out our code labs, where it's a step-by-step guide on how to build in all of these narratives as well. And of course, if you want to stay up to date, follow us on Twitter and use the hashtag AOGDevs so that we know all the cool things that you're doing. And if you want to have conversations with other AOG developers, feel free to join our Reddit community. That's where you can ask questions, answer questions, and just be part of the fun as well. Thank you so much.
Awesome. That was a fun talk, Jessica. And I'm glad you recorded it.
Yeah. Oh my gosh. It's made it a lot easier because you can imagine saying the same thing over and over again.
Yeah.
Because I play in this world so much, I forget to explain all the key terms and all that. So this really helped to make sure I nailed all the topics.
Yeah, that's awesome. Let's do some Q&As. I know that you have some demos as well, but let's start with some Q&As.
Exactly. Good.
Where is that one? Okay, right here. So when you say Android app, could it be Flutter app as well? Somebody is new to apps and Flutter, and they think that Flutter is quick. So
Yeah, definitely. So as the way that we have the our Android apps or app actions integrated is using, as long as you have a Play Store configuration, and ideally you're using Android Studio, then you should be good to go because we have all our testing built off of that. Me, myself, I actually haven't played with that, so I don't want to say 100% yes. But if that's not the case, I need to find out because I don't, our Flutter community is huge. We want to support them. So I don't see why we didn't, but by all means, I would say if those two statements are true, then it should be good.
That's awesome. We see more comments and more compliments on the video. That's awesome.
Yeah.
Nice. Question about iPhone users? I don't know. Maybe I don't understand the question.
I don't
I would
see
not.
it.
I would like to ask, what about iPhone users?
Ooh, yeah. So
Work on the same?
totally. So with iPhones, all you have to do is download the Google Assistant app. And as long as you have the app, then you have Google Assistant. And so all the possibilities of Google Assistant is available to you.
Awesome. Do you want to do the demo?
Yeah, definitely. Yeah. So there's kind of big chunks when it comes to this narrative. And there's the mobile side, there's the web side, and then there's also the smart home side. But the kind of fun part or the really creative space is the conversational action side. So I would love to show a demo on how that tooling works. So let me just present my screen.
Awesome.
Yes, please share. Oh, goodness. All the tabs I have to push. Be like, yes, please share this thing. And of course, I shared the wrong tab. So let me undo that. I would like to share. Goodness gracious. Where do I? Oh, here it is. Haha. Sorry, I have too many tabs open. That's pretty much my problem. Okay, great. It looks like I'm sharing. So this is the Actions console, especially for those who are not familiar. And I am in the test section of it, which means I'm in the simulator. And so I could simulate the conversation. And so I would love to first show a really simple demo of like the interaction. And then we could go in and I could kind of pull apart the action so we could see how it's built. And so on the left-hand side, what you're going to see is what the user will see on their phone or smart display. You can also change that by changing the settings up here, but we're going to leave it on smart display. And on the right-hand side, this is all going to be the history and like logs. So let's start this action. And you could do it by either clicking enter, you could push the suggestion button, or you could click on the microphone and say it. I'm going to just hit enter because it's a little easier for me. And this will start our action. Great. Because I'm wearing headphones, you guys can't hear what I'm hearing, so I'm going to turn off that volume. But it's speaking right now. But because I have my headphones on, I can't record it or can't do the audio. So on the left-hand side, as you can see, there is the device. This is the what the action is saying. And then it also has some suggestion chips. So this is just saying, welcome to Actions Builder Demo. Can I give you a silly nickname based off a few questions? And so we're going to say, actually, I'm going to say yes. Sweet. And then I ask the next question, what is your favorite basic color? And here I'm going to go with, let's do yellow. Great. And then it's asking out of the 3, which one's my favorite? Oh my gosh, I love dogs. Fantastic. Oh, I have this action set up to immediately exit, so that's why it didn't show up here. But on the right-hand side, you can be able to see the last bit of it. It says, great, give me a second to think of your perfect nickname. I got it. I'll call you Sunny Puppy the Brilliant. Bye. And so as you can see on the right-hand side, there's just the history and the logs of the conversation. So everything on the right of this scene or this section is what I said or what I did, and on the left is what the action said. So that is just a really simple demo where it's asking 2 questions and getting 2 pieces of data to generate a response to the user. So let's see how that happens. I'm going to go on to develop. And in here, let's walk through the whole action. So I'm going to click on main invocation, because that means this is the main way a user can come into your action. There's other types of invocations, but by the name suggestion, this is the main one. And so when someone says talk to action demo, what happens is our action gets invoked. I'm going to minimize the screen just for a moment, and then it's going to transition. And so from here, this action gets invoked, and what we're doing is we're going to call our webhook to get a greeting. And so I'm actually hitting my webhook. I have a server set up, so whenever it receives this function call of greeting, it generates the greeting and gives it back to the action. Then it transitions to the start scene. And in here, this scene is all about setting things up and like figuring out if the user even wants to play. So the greeting gets added to the queue, which is the conversation queue. And then the on enter gets triggered. And this text of the question, can I give you a silly nickname, gets added to that prompt queue. And that prompt queue gets delivered at the end of evaluating the on enter condition and slot filling. That gets delivered to the user. And that's why we could get the greeting plus the question all in one seamless flow. And then the really interesting bit is processing the user's information and what they said. So after that question is given to the user, right here, I have a user's intent handling, and I have it when yes is matched and when no is matched. So if the user says no, it's going to end the conversation. And if the user says yes, it goes to the next scene. And I think this part is usually the bit that people are really interested in, is how we do that. So let's go to our intents. So I could show you when it comes to the yes intent, this is something I made. And I added different training phrases. So I added different ways a user might be able to say yes. And what happens is the Google Assistant's natural language understanding will build off of this and use other examples to expand this. And so a user could say a different variation of this, and Google Assistant will most likely be able to figure out, oh, if they said something of a variant of yes, it most likely will be meaning this particular yes in this scene. Oh, sorry. So that is how you can add different types of intents, as you could just add to this phrases. And with my no, it's similar. So if I click on my no intent, it's going to be all the opposite words for no. So after the user, let's go to the scene of, oops, that's not a scene. Let's go to the scene of start. And actually, let me mute myself because so sorry. I have been playing with a 2-year-old all day yesterday, and I think my voice is strange from that. So when the user says yes, let's click on what happens. So the intent gets matched, and then it transitions us to the silly question scene. So let's click on that and go to the silly question scene. And in this scene is all about gathering data from the user. So what happens is, when we enter the scene, it's going to check to see if all my slots are filled. If my slots double equals final, that means they're filled, then do something. But they're not at this point when we first enter it. And then it goes and checks slot filling. And I have 2 slots. I have favorite color and favorite animal. And so my action is going to actually ask both of these and be able to process that. So it's going to grab that information from the user. It's going to ask the appropriate questions. And then once those are filled, then the slots get satisfied, and then it moves over to end the conversation. And I think based off of time, I think I'm at time. I'm not sure, Vikram, if I have a little bit more or if people have questions. It does look like we have some questions. People are using Flutter. If you were to use Flutter, would the user need to have Google Assistant already installed in iOS? So if they have an iPhone, you have to install the Google Assistant app, so then the user can trigger any Android apps that are, or any apps that are on their phone. I think there are some limitations when it comes to certain versions of iOS, being able to access certain apps as well. So that's always tricky. I think that's just inherent because it's an iPhone and we don't control that. So I wouldn't say it's guaranteed when it comes to activating opening apps on the phone itself. So that is always something that is a little tricky, simply because we don't own that. But if it's an Android app or an Android phone, definitely. If a user says something, you can add in. One of our common built-in intents is open app, which I think is fantastic for any application. So if you have an app called, I don't know, Puppy Fun, then what you could have, you can incorporate that built-in intent. So then the user can say, hey, G, open Puppy Fun, and it'll open the Android app on your phone if it is already installed in your phone. Let's see, there's another question of how long a conversation can be had with Google Assistant. And so that comes into an really interesting space because, let's see, actually, let me turn off my screen. Because the Google Assistant can continue conversation, and as long as you're talking to it, it'll just keep answering, so you can keep going. When it comes to actual actions, oh, excuse me. Ooh. I've been having a really good time this last day with my nephew, so sorry. But when it comes to actual actions, you want to keep those a little shorter, a little tighter, unless they are meant to be a longer game or an experience. So if you're doing something or focusing more on a productivity or trying to get things done quickly, those conversations are usually shorter. Fantastic. Does the Google Assistant SDK work alongside Dialogflow? And what are the differences? Also, how does the Actions console have a visual builder similar to Dialogflow CX? That's a great question, Chris. So Dialogflow is another tool that Google has, and it is more aimed towards kind of the chatbot kind of space. And sometimes people, you could argue that they're similar voice and chatbots, but the way Google Assistant is aimed, it's more conversational, it's more voice oriented versus Dialogflow, it's more chat oriented. And so those are kind of the big difference between the two. We have a new Google Assistant SDK that we call Actions SDK that got launched in June. And so that SDK and Dialogflow, because they're built on separate kind of tooling, don't play well together. And so generally you have to make a choice as a developer, whether you want to build with Dialogflow or if you want to build with Google Assistant and using that tooling. With Google Assistant, of course, I'm going to recommend using the tools that we built for Google Assistant, so using the Google Assistant SDK, simply because it's conversation oriented. Versus, again, Dialogflow, nothing against Dialogflow, it's aimed for a different population. And then let's see, when it comes to the functionalities between the two, when it comes to the Google Assistant platform, there are differences between what you can do and what you can't do when it comes to features and tools. I believe there was another part of that question was, how does the Actions console have a visual builder similar to Dialogflow CX? Because it's a good way to build things, which was really funny that we launched that, and then a couple of weeks later, the Dialogflow CX was launched. And I think this has to do with the space of chat box and voice. We're still, as a technology and as developers and people who are building these things, are still trying to figure out how do you get a conversation, whether it be through chat or through voice, and visualize that in a way that makes sense, that's still flexible. And there's a lot of different products that are aimed for this, and we haven't figured out the best way necessarily. And so I think this is a best first stab or second stab at trying to get this done too. So I definitely, when I saw it, I was like, oh, theirs is really similar. But we're different teams. Like, Google's so big, so there was definitely not a cognitive decision. We should kind of have the same things. I think we built similar tooling because it kind of makes sense to do it this way. But again, this is new technology that we're still trying to figure out, and there's not a this is how you do X yet, which is really exciting, but at the same time could be really frustrating because it's all new. So yeah, I hope that was helpful, Chris.
Yeah, and those were really good answers and good questions as well, of course.
Yeah.
Nice. Thank you so much for joining us today, Jessica.
Of course.
And hope you can have more time with your nephew.
Yeah, thank you so much. Thank you for having me. Oh, it was a blast. I definitely miss this community. This community is amazing.
We definitely miss doing this in person, but yeah,
Right.
thank you so much.
Yes, perfect. Thank you so much. Thanks,
Have a
Vikram.
good day. Bye.
You too. Bye.
All right. Next up, it's actually me. So I'm going to start sharing my screen, and then we will go through it. Let's do it. All right. There we go. Okay. Hello, everybody. So now it's time for yours truly. I know that you've already forgotten about me, so I'll just start with an introduction. Why not? So hey, everyone. Thank you for joining us today. My name is Vikram Tiwari, and I'm co-founder for Omni Labs, where I handle all things tech. I'm also a Google developer expert for Google Cloud and machine learning. So if you have questions related to that, I'll be happy to answer. At Omni, we are working towards building solutions for personalized process automation on the web. We are looking for next passionate engineers to join our team and help us build the future of work. Please feel free to reach out to me. My email is right there on the slides. It's Vikram@Omni Inc. Or send your friends my way. I'm happy to talk to them. Now, long before we started Omni, I had a dream. My dream was to become a rock star. Because why not? I'm sure most of you also had that same dream. Please comment that in the YouTube comments, and then we will talk about it. If you had the same dream, you're in the right place. Please let me know in the comments how it worked out for you. So I had this dream, and I started looking for it. What would I do to get that going? When you look at it objectively, you really don't need a lot of things. You get an old guitar, get some practice playing it with your band, and then play at the world stage, right? Simple. Fortune and fame, all of those can be yours. Nickelback gave me high hopes. But it will be an understatement to say that music sense was just not into me. Things did not pan out at all. And I had to rethink my life choices. So I started focusing more on my engineering studies. During that time, I came across the concept of sound. And here's a quick primer for you. What is sound? It's actually just a disturbance into the waves, into the particle nature of our environment. So it's just some disturbance in the force. So what's music? Music is whatever speaks to you. It's just those sounds, and when they combine together, you can make some music. So can we actually make some music? So to make a music, you make some noise, add it to a timeline, and add some variations. That should be good enough, right? Let's add some programming to the mix. Can we actually make a music make it machine, or machines make it music, which will be as simple as we will generate some tones, we'll add them to a timeline, we'll randomize the timeline, and then we will see if it can actually generate the music. So before we go into that, let's see how it will actually work. So JavaScript provides a good way to do all of this. You can create an audio context. You can create an oscillator in there. Oscillator is the thing that will oscillate to generate these waves. you can give it a type of wave that you want to generate, and then you can connect it to an audio node so that it can actually emit the audio outside. And then you can stop the oscillator, of course, when you are done with it. So programming to the rescue of my career of Rockstar. So let's see if it can actually work. And if it works, then I'll just pretend on the stage. Why not? Like everybody pretends. I'll just tune my guitar. All right, let's see. A demo. Now the thing is, they won't transmit this audio properly, so I'll have to do this multiple times. All right, Rockstar. There we go. All right. All right. So let's see how actually it works. So there are different types of waves that you can do. First is sine wave. This is a sine wave. Then we have square waves, triangle waves, and sawtooth wave. I just want to confirm that people heard all of those. Can somebody confirm that to me? Nice. Okay, so people can hear it. So just to repeat again, to generate music, what you have to do is you have to change particles into the air and you oscillate anything. And when you oscillate, you can oscillate them in different waves. So those waves are sine waves, square waves, triangle waves, and sawtooth. Of course, you can generate more different types of waves as well. Then another variation that you can add when we are generating sound is to add a frequency. So let's try adding those. That's the 261 gigahertz, which emulates as C4 key, which is an A4 key at 440 hertz, and at 830 hertz, G minor 5, G5 minor. Now, what you can do is you can add these waves and these frequencies together, and you can generate more, you can generate more variations. So let's try those out. This is a square wave at 174 gigahertz, hertz, not gigahertz. That would be too much. And this simulates F3. Similarly, we have a C sharp, C6 sharp. I keep messing it up. Then F2. So essentially, with these few parameters, what we can do is we can generate a lot of different tones that we hear in every day. So all we need at this point is make it randomized. Let's try it on. How was that? I have to stop it. Okay, how was that? I'm sure that was not fun. It sounded like some noise coming out, but not really. Let's take a look at the code as well, so that we know how it actually works. So here we go. The whole code is dependent upon this. We generated some notes values. We have some possible waves that we wanted to generate them with. And what I had to do when I was building this is I had to find out all the different notes for all the different frequency values for all the different notes and join them together. And then object.values for those values. And just we combine both of them together. We create the oscillator node, we add the gain in there, we get a type, a random type, and random frequency, and then we just add it to a queue and play it. And when we play, the play function will just take a random value of the sine wave or cos wave or sine wave, square wave, or triangle wave, and all those, and then it will just play those. So that's actually this is the whole function that does it. It plays both of those values. It's not great, and as a result, we see that our music is also not great. So we go back to the point where, yes, we can generate the music, but it doesn't really speak to me. We are at a point where music is great. This music is working, but it doesn't work. You see the issue, right? Like I can use it for Nintendo DS, and if you have spent some time playing Mario and Pokemon, that might speak to you, but not otherwise. So let's assess our situation at this point. I spent some time in here. We did a lot of work to get to this point on the programming side, but let's see what are the problems that we ran into. So challenges that we ran into are complex sounds. If I had to create a drum, it will be very hard to recreate. I will need to know all the different frequencies that are there, and then I'll have to write all the code to make sure that I can actually recreate that drum sound. Second, order of the placement for these tones matters a lot. I can't play a really high note and right after that play a really low note and then repeat that multiple times. As soon as I do that, it doesn't feel good to your ear. Like, of course, it's a jarring experience. And then pure randomness is also bad. It actually needs a personality. If I do pure random noise, it doesn't matter what I'm playing. It needs some kind of personality in there. At this point, my programming skills gave way. I remember at one point I was reading different research papers on how to generate random orderness, and it just didn't work. So I was stuck and sad a little bit. Years went by. Then one day, something unexpected happened. I came across the concept of machine learning. Of course, it's been around before even I was even born, but it wasn't really feasible, and it wasn't much. Also, the concepts of deep learning were starting to take solid shapes, and they started forming the backbone of the new era of machine learning. So what is machine learning? Machine learning is actually fairly similar to traditional programming that we all are familiar with. Traditional programming focuses on users knowing all the rules. We have subject matter experts who come in and they program these rules. We discover these rules through our user experiments and things like that. And we program these rules and write these rules into software. So the same thing that we did for building our music machine. We learned the rules which govern the music, like the sine wave, cos wave, and the frequencies, and we tried to use it as the data to generate the music. And those rules and that data give together the answer. And it's very straightforward. You will always use the same rules. You will always use as matched rules as possible. And same data will always return in the same answers. That's the traditional programming way. On our machine learning way, it's fairly different. On machine learning side, you are trying to not know or you are essentially helping machines learn all the rules. So what we have is all the answers and the data, and we give it to our machine learning models. And these models use this data to learn what are the rules of this machine learning, of this system, of this data to get to these answers. So the equation changes a little bit. But overall, end result is fairly similar. One more variation that machine learning adds is your answers won't be 100% accurate. It will be a variation of that. It will be 50, 90, 80. You are trying to get as close as possible to 100, but it won't always be 100%. So now, what is this deep learning that we keep hearing about? It's just a specialized form of machine learning where we have multiple layers of neurons to train a model. Now, each neuron, you can think of it as something that learns something about a problem, a specific thing about the problem. It could be a color, it could be edge, it could be size, it could be shape. But it tries to learn those details about the problem that you're trying to solve. On audio, it could be the waves form and things like that. And throughout the layer, it tries to make that choice even better. In naive terms, they act as filters. These layers act as filters, which get trained to allow only a specific type of data to go through. And with multiple layers of these filters, we get the result that we expected. So on this example, we have an image that we are passing through an input layer, and through multiple layers of activated neurons, we get to an output layer where our deep learning neural network can determine whether an image has a cat or a dog in it. Now, you can also try these on your own machine. This is playground.tensorflow.org, and we can do a quick demo of that. Let's do this. Playground.tensorflow. All right, actually have the whole URL. So here what we have is essentially a neural network which runs in your browser right here. There are multiple different things that you can tweak around, but what we will try to do is we'll try to go with simplest possible problem in here. We have the problem that we are trying to solve here is classify orange dots with blue dots. And we're trying to build a model, a deep learning neural network in here. And we will try to train it. Let's train it. And very quickly, we see like within 50 some epochs, which is training the whole data once, we have a model which is able to learn the classification of orange versus blue. Now, as you can see, this is not a great representation of exactly what's going on inside the model, but it is a fairly good representation. So what we have is we had two different kinds of simple features that we tried to feed in. One is a vertical line, another is a horizontal line. When we feed this data inside our model with multiple hidden layers, these are the different layers of a deep neural network, we see that each layer is trying to learn something different. So this layer here is learning edges, and each neuron is trying to learn different types of edges. As we go deeper in there, you will see that another layer of neurons will learn something different as well. So as you add more and more, as your problem becomes more and more complex, you can add more and more layers, and you will see some kind of solution. It might not be the correct solution, but you'll start seeing some possibility of the solution. There's, of course, a lot of practical research and machine learning theory that goes into actually finding these solutions. But in very generic form, you can do this, and you will see some results. Let's see another problem. And another problem said, this data is fairly similar. We can, again, use these same two features to get the answer to this. Let's see, try it very quickly. Like even, like I'm sure you can decide this. And we see that the features that it learned in the second layer of neurons are very different from the features that it learned earlier. I'll suggest you give it a try and try to find a solution for this one. I can promise that it's fairly complex, like we can try running this. But as you can see right here, with just these two features, we are actually learning straight lines. There are some edges in here, but it can't really do much in here. Like this will take a long, long time for us to actually converge and get to the answer. And it doesn't seem like it might even not be possible. At this point, what you need to do is you need to find some more features. This one looks like a good one. Should we try it? Maybe add some more neurons. Maybe add some more neurons here. And why not add a new layer, right? Let's try it. OK, we see right here, yeah, it's actually doing something better somewhere a little bit, maybe. I'll suggest you go through it and try to get to the answer of solving this problem. You can see, again, it's learning at different layers. It's learning different variations. And you will see you can play around with this and get through trial and error to find out exact answer. All right, back to the presentation. So that's a neural network that is running in your browser. Of course, another thing that you can do is we know that we are using these machine learning neural networks, deep learning neural networks in self-driving cars. But you can also train a self-driving car in your own browser. Of course, it's a simulated environment, but nonetheless, it works. You can. All of these things are powered by TensorFlow.js. The playground TensorFlow is just a very older version of TensorFlow.js, which is called, I don't actually remember the name, but that was the previous project that came in before TensorFlow.js. But they are all powered through the same technology. And with TensorFlow.js, it essentially is the JavaScript code of TensorFlow core library, which is written in Python. I really enjoy using TensorFlow.js, and we'll talk a little bit more about that. But what can you actually do with it? You can run an existing model, which is a model that has been built by some external team. Google has a lot of those. Hugging Face has a lot of those. And you can use those existing models in here inside JavaScript, or you can convert an existing Python model into a JavaScript model. Then you can also retrain an existing model. Let's say you have an existing model which was built by a larger team. You take that model in and you retrain that for your own use cases. You'll see an example of that as well. And of course, you can write your own models from scratch. So let's take a quick look at these things. Let's do a toxicity check detector. So this is a model that TensorFlow team has written for us, where it tries to find the toxicity of a sentence that user has pushing in. So to do this, it's fairly simple, as you can see. All we had to do, this is an actual web app on which it is happening. We imported TensorFlow.js. We imported the model, which is the toxicity model that we are trying to import. We use simple JavaScript methods to await and load the model. Of course, you want to wait for it because it's a bigger file. Then you pass it the value that you're trying to classify. Once you pass it the value, it will give you the results based upon what is happening. So it seems like this is an identity attack. There's a probability involved in here. And what is the match? Is it an insult? That is true. Seems like an insult, of course. Let's actually try this in reality and an actual example. Let's see, where is it? Right here. OK, so rather than saying you suck, I will say COVID sucks. Of course, I don't get the pizza. I can't get the pizza. All right, let's classify this. So what's happening this time is the first time that I ran this model. It downloaded the model from Google servers and it ran the classification on it. Identity tag, false. Insult, doesn't seem like it. But toxicity, yes, there is some toxicity in this. So you can use actually this model if you're building a chat forum or something like that, you can use this model right there. Let's take another sentence from somewhere. Let's use this, why not? It seems fairly neutral statement. We'll see what the result comes out. Now this time it's a little bit faster than earlier. And all the different checks have gone to false. It's not an insult, it's not a threat, and it's actually fairly neutral statement. So this is a one demo, but if you go to playground.tensorflow.js, you can see more demos that the team has built. And you can, of course, play with them and all of them work on your own local machine. Next, you can take a Python model and use TensorFlow.js converter tool to convert that model. So TensorFlow.js team, of course, they are trying to make as many models as possible available to us directly, but they can only do so much. And your team might have some models that are not available to TensorFlow team models, the TensorFlow team. And what you might want to do is you might want to use those models to be served from a web page or into TensorFlow.js. So you can easily use TensorFlow.js converter tool and convert your Python-based model into a JavaScript app. It helps if the model is in TensorFlow 2 format, TF2 model format, but if not, that also should work. Then finally, how do you actually create your own model? So creating a model is actually fairly similar. If you are familiar with Keras API, it's almost same as that with JavaScript involved in there. So define the type of model you want, which is sequential model that we are building in here. Then add different layers. Don't forget to add the activation layer. So here was of like adding a convolutional layer, adding a max pooling layer, flattening those, and adding a dense layer. So you can add different types of layers in there. And don't forget to use your activation functions and different parameters that you have to pass in. And then you compile the model. When you compile the model, you can add a loss in there. You can add an optimizer that it will use to actually train the model. And then finally, you can start training your model. This training can be done from scratch or using transfer learning. Now, once you have trained your model, you can save the results into local storage so that you don't have to retrain that model every time the user is trying to use it. Of course, you can download the model directly at this point from a server and get started from there. And once you have the model, prediction is as simple as just passing your input and you get the predictions out. So let's see next. Why would you want to use it? So if that's not enough reason, like, of course, the API is simple, you can convert any models. If those are not enough reasons, let me give you one best reason that I really enjoy working with TensorFlow.js, which is the possibilities of using TensorFlow.js models are endless. Almost anywhere that you can run JavaScript, you can run a machine learning model now. So if you build a model which can run on browser, that same model can be used to run on mobile, same model can run on servers and desktop machines, of course. It supports Node.js. It's able to utilize your hardware infrastructure from GPUs. I don't think it can use TPUs, maybe I'm wrong. And it can essentially write once, deploy anywhere, the promise of web, and that's why Team Web. Yeah, and another good thing about TensorFlow.js models that you can use this way, that you can make them totally offline. So some experiences, like the toxicity model that we just used, that it was totally offline. None of those requests were sent to Google or any other provider. All of those computations happen totally on the local machine. So you can be very focused towards privacy and preserve the privacy of your users while you're using TensorFlow.js-based models. Let's do a quick recap. With TensorFlow.js models, you can use a pre-trained model for off-the-shelf models. These are the models that other teams have built that are available in the open source. You can also convert an existing Python model. These are the models that you have, or of course, open source available models. You can train your models in the browser as well as using Node.js. This is training as well as inferencing, but you can do both of those. And once you have the model, you can deploy it on various platforms, ranging from small mobile devices to even IoT devices. Now IoT devices support Node-RED. I think that's the project. And with that, you can include TensorFlow.js model in there as well. And of course, once you have all of this, why not get some profit, right? So now the question is, with all of this technology, can we actually fulfill my lifelong dream? You thought I forgot about it, right? No, I'm still focused on that. So can we actually use it to generate the music? Okay, let's see. It's time to first find a fix for all the problems that we had. We know all the problems that we had. So here's some techniques that we'll be using to fix those problems. First technique is called style transfer. The way style transfer works is it learns from the patterns of different styles that you use to train the model, and then it retains that as a memory. And then you can transfer that over a new data. So what's happening in here, I don't know who the artist is, but the model has learned the artistic styles of different artists in here, and you can pass that style to a new video or image or any other format. We have different types of models that have come out of this, and you can use them. I'm sure people are already using these kind of models. These are very famous in photo and video editing apps right now. So remember that our music didn't really have a soul. I'm not a god, but maybe we can use style transfer to build a soul. It's a copy, but works, whatever. Next up, remember that our tones didn't really have a rhythm to them. Now, the rhythm is actually an interesting problem because it's not just what you output right now. It's not an output in an instant. It is determined by some information that was there beforehand. So a rhythm can't be just a point in time. It needs to remember something that was happening before it. And that's how you can actually form the rhythm. So for this, we are using recurrent nets. With recurrent nets, they allow you to make sure that it can capture the temporal information. And with temporal information, you give it, like in this GIF, what is happening is we give it at the start point of an information. So if I'm trying to draw a cat, I draw a circle. That's the start of the information. And then the model can determine what comes in next because it has learned that over time based upon its previous experiences or from the previous data that we've been using in here. So with that, we will be able to actually generate rhythm in our music. Next up, remember that we actually gave up after a few tones because I was just too lazy to write all these different wave functions to generate the drum sound, and then we will need some more sounds, of course, like as many as you can add. I'm just too lazy to do all of that. It's so time consuming. We will have to rewrite and like listen to that for multiple hours. It's no fun. And of course, I'm lazy. So what we will do is for that, we will use autoencoders. Autoencoders are very good at learning the nuances of data in an unsupervised manner. We will be using a variational autoencoder, which is just a form of autoencoder. But what they allow you to do is you can give different inputs to it, and it will try to reconstruct those same inputs based upon the inputs that you gave it. So in essence, what it's trying to do is rather than us teaching all the different strokes and circles that you can use to create a cat in here, it is learning all those different variations on how to create like that ear that is on the cat's head, like how to make that. It's learning on its own, and I don't have to teach that. That's so much easier. So what I can do is I can give it a lot of examples on how to draw a cat, and then it can learn on those examples on how to draw a cat by itself. I don't have to train all the whiskers and all the different complexities of this. So at this point, I think we are actually ready to create our model and get cooking, right? Should we do it? Not really. Before we get there, let's remember one thing. Anytime you are trying to do this, let's always try to keep humans in the loop. Anytime we are building a machine learning system, it helps not only to catch these various issues that we run into, but of course, our machines can handle humans in the loop. It also helps with understanding, like most of these models that we are building, they are for the humans. So there's no point in not doing that. And with humans in the loop, what we are trying to do now is we will try to give it a sequence of 2 inputs or few inputs, and we will ask the machine to determine the sequence between those. So our goal would be that we give 2 endpoints, and the machine will generate the whole sequence between those endpoints. So here the example is with the cat and mouse images, but we will try to use the same example in generating the music sequence. So at this point, should we do it? Okay, I was actually starting on that. And then, this one thing called Google, and if you actually form your search query well enough, it has all the answers. And I ran into this. It's called Magenta. Magenta is a team inside TensorFlow team. They are a group of artists and musicians and researchers who are working towards generative model research. Their whole goal is to work towards generative model research in an art and music domain and build creative tools. And the best part, they make all of this open source. When it's open source, just fork it. Why do you need to write all the code, right? So let's see what they have. All right, demo time. Stop sharing, share again, Chrome tab. All right, so here's the demo that Magenta team has built for us. Now we will first start with melodies. This is a variational autoencoder model that is called Music VAE that has been used to build this model. It's been trained on a lot of MIDI files. That is a limitation right now on what kind of files that you can use to train this. It has 256 features, and you can tune these features here. As we can see, like I can just tune some values in here, and they will generate different results. Or you can just ask to get another random sample. Let's try actually playing with this. So what I do know, after playing with this enough, that which one will be a good sound. So let's see actually how this works. So it actually sounds like music, right? This is actually really good because it's a complete melody. Let's try some other samples. Maybe not as good. Let's try another sample. All right, I feel like this is going to be a good one. I'm not the only one who's jamming to this, right? Let's get another one. Now you will notice that this model did not require any of the programming, and all the features are right here. All the tones that you are listening, these are the tones that were already recorded from previous data, and it's using that learned data to generate these tones. So we are actually really close to generating the music. Let's see if we can do this with all 3 devices. Right now, we just went through piano. Can we do it with guitar as well as the drums? All right, so we are downloading the model right here. We have, again, more features. And let's see if this will work. That feels like an actual band, right? I'm not the only one, right? All right, let's try another sample. Just one last more? Sure, why not? All right. So I did promise that we will go and try to clone Bach. Let's actually do that. why not? We are at a point where we can actually generate the music. So let's try to do it with Bach. All right, so here we have Bach. He was a great composer, and we will try to learn from him. He's doing a really good job. I don't want to interfere. So Bach just taught us that you can use 4 different types of melodies to create a really good melody. 4 different, I don't even remember that terminology. So what we're going to try to do is we're going to make our own here. So let's add some notes that Bach can use to generate a proper melody. No, I want a single one. All right, at this point, this is the input that we gave to our Bach model. And then it will try to use this input to generate the 3 more variations, and then it will play those. That was delightful. For me, at least. I don't know how others felt about that, but that was delightful for me. Let's close this. All right. Nice. Okay, so we did with Bach as well. Bach didn't mind that we are using his music to pirate it out. All right, so what's next? We just learned that we can do this now. I'm actually happy that I was able to do all. We were able to do all of this. So what's next for Magenta team? They want to add more instruments to this. Of course, the reason we just saw that it's hard to do all of those things. And as you have more data from different instruments, you can start adding those. It will be fairly easier, much easier than what I was trying to do. You can add more themes and more styles. You can also start using generative adversarial networks. These networks are the networks which will try to train themselves to do better music. And if they don't, they will diminish it. So the end result ends up being that you actually get a really good model which can actually generate music on its own without requiring any training data, in a sense. If you want to help with this, you can start publishing your music in the public domain. As you might have just guessed right now, is all the music that we have to actually generate these right now, it's the music that is in public domain, and that's why we are using Bach's music and not some of the recent performers. And that's why if you can share your music in public domain, that will be very useful. I'm sure if I tried on Eminem songs, he will mind. But yeah, so it's time for some reflection. Reflecting back, I'm actually low-key glad that I did not try to pursue my dream of being a rock star. I would have missed out on meeting all of the fantastic people that I do meet and all the cool things that we are doing at Omni. I'm also very unsure that even half of you would have come and attended my concerts. So if you have any questions or compliments, please feel free to reach out to me on Twitter. I'll take all of those things on my Twitter. Finally, before we go, a few things from my side. If you actually just want to generate different variations and try to play with the music and just want to have a good time, the first link, which is medime.pledge.me, you can go in there and just play around. If you actually want to learn more about how to build autoencoders, that's the technology that we used in here, you can go in, and Kara's blog has a really good blog on that, and you can learn it there on how to build autoencoders. Then finally, this one is a really good one. If you actually want to build your own models and don't want to worry about all the different details about how to build models, head over to Teachable Machines. I think we have time for a quick demo, and I'm going to just do it. All right, so here we go. Here is Teachable Machines. Teachable Machines essentially is a platform where you can come in and train your own data to generate a new model, and that model will work wherever TensorFlow works. So of course, wherever TensorFlow works, wherever P5.js, Coral, Node.js, everywhere it will work. So let's get started. For this, I'm going to build a new model, which will be an image-based project. All right, let's do it. Now, you can, for image-based classification models, you need different classes because you're trying to classify between those. So first class, let's make that myself. All right, let's add some images of myself. Here we go. All right, 45 images, that's good enough. All right, class 2, let's add a mug in here. So I have a TensorFlow mug in here. I'm just going to get out of the frame, and we will record TensorFlow mug in here. All right, 50 some images for that. And then we will try to do a last one with my phone. Add a new class. And this is my phone. So hold to record. This works. All right, let's see. All right, so we have 3 classes right now. What we are trying to do with this model is we will try to classify between 3 different types of images. There's Vikram, you can classify it as me or a mug or a phone. So let's train this model. Just remember, this is TensorFlow.js. None of this data is going anywhere other than my machine. Whole training will happen right here on this machine. So let's start training. It's happening. Of course, it's going to download the core model. It's going to train on top of that. And we have to keep the tab open, of course. And 50 iterations of training. Going. All right, so we have the input output here now. So you can start testing this model right here. Of course, it's me. It is very good at that. Let's see. Yes, phone. And here we have mug. Fairly quick at identifying the difference between me, mug, and the phone. Now the best part, you can export this model from right here and take it to TensorFlow.js or TensorFlow Lite, which will allow you to use this model on a Coral device, Android devices. I thought that they had iOS, but I'm sure you can do that. You can generate your own iOS device model. And of course, you can get the complete Keras model in here. You can also just get the saved model right here. Like this saved model, you can just download that and just use it. With this, you can essentially, like if you have some small problems that you're trying to solve, you can just start using that. And you can start using that and share those things. And finally, at this point, I will stop and I'll take some questions. Thank you, everyone. All right, so let's see questions. Questions. DJ Vikram, thank you. All right, we have the first one in here. Vikram, this is of constructing the model. How do you do it with Jupyter Notebook? Oh, so the actual model construction that we did, all of those models are available from Magenta Project, and Magenta Project releases all of those in Colab notebooks. So Colab is a technology. If you just search for Colab, I'm sure you will find it. It's essentially Jupyter Notebook, but hosted for free for you by Google. And you can save the outputs or those notebooks directly into Google Drive, or you can download them, or you can save them on Google or GitHub. And that way it doesn't require you to install any of the software on your machine. So I think Magenta team shares all of their work. Of course, models are directly available, but everything else is available as a Colab notebook. So you can try these things out and change the model and provide your own soundtracks in there to generate the model. Yes. Nice. Very robotic. Of course, yes, that was the problem. Time to add. I'm sorry, we don't have that Spotify playlist, but sure. Is this the construction of the model? That's good. All right, drum rolls. This one isn't half bad. Is there MIDI support? Yes, that's actually the only support that we have. That's one of the problems that we have while trying to train models around sound. Is the MIDI is actually a really good format when you're trying to train audio-based format, because almost everything else is compressed. So MP3 is a compression, and any other things that you go into. There's also compression, and that takes a lot of time. And like it doesn't really have all the data. MIDI really has all the data. So MIDI is the thing that actually we support very well, and everything else is not as a good support. I'm saying we, but it's just the whole Magenta team. I'm not really working on that, but it was I'm glad to represent them at least here. All right, what else? Link to the slideshow. I'll share the slides afterwards when the album's dropping, hopefully soon. Bach music site. All the links will be in the slide deck, and I'll share the slide deck. All right. Have you used sounds on teachable machines? Any suggestions? So again, all the examples that are on teachable machines right now, those are classification-based models. So they won't actually do any generation. You can use them to classify. My friend actually built a really cool, not using teachable machines, but the similar principle, where they built a model of detecting when their dog was in the room versus not. So they have just a white noise, which is background noise, which they trained upon. And then once where their dog was barking or their dog was just making some noise. And they built that as a very simple classification model, put it on a Raspberry Pi, and it's just in their home. And when they are at work, which used to be, not anymore, but when they were at work, they could very easily understand that their dog is in need of something or is just in that room versus not in that room kind of thing. So you can definitely use teachable machines for sound. None of those, again, as I mentioned, all of these models are TensorFlow JS-based models. They are not passing any data to anywhere else. All of this training is happening on your machine, but it's only limited to classification right now. So you will have to make do with that. If you want to do more than classification, you can, of course, there are samples available for this online. You can take an existing model, retrain it for your own use case, and just utilize that and whatever problem you're trying to solve. Retraining models is a very good way to go for it. First thing I tell people is go find a model that is existing and retrain it for your use case. Another thing I want to highlight in here is teachable machines is a good start, but if you are building things in a production environment kind of scenario where you will get new data and you want to utilize that new data to retrain, you don't want to go back to that page and train all these things on your local machine because it will take a long time. For that, I would suggest using Google Cloud AutoML. Google Cloud AutoML allows you to train different types of problems, not just classification. And those problems, you can train them on Google Cloud. So you can keep adding your data onto the existing data. It will retrain your models. It will give you the best models right now. These are models which are lightweight and not like we did only 50 iterations of training. On Google Cloud, you will be able to train it for longer and thus get better models. So I would definitely suggest if teachable machines gives you enough understanding on how you want to build your model, you should go forward and take a look at Cloud AutoML. It is available for vision, data, tabular data, videos, I think audio as well. I'm unsure, but I'm sure you can take a look at that. Nice. Teachable machines will be the future. I'm expecting it to be, yes. Like, why not? Everyone should be able to build their own models. Recording of all the talks, yes, they will be available. Bach music site, I'll share the link. Link is in the presentation, and I'll share that as well. Yeah, like I can't spell it. It's a long name. Sorry. Nice. We have a few more minutes. Let me actually do another demo in a few minutes. Let's see. Share my screen. So I talked about TensorFlow JS team has a lot of models on their side. So let's do this js.tensorflow.org.js. All right, so right here, you can see a lot of demos that they have built up. And we did one of the ones in there. Which one did we do? It's not even here anymore. All right. So you can try out these different demos in here. For this one, you actually need a phone, and that it works really well because you have to hunt the emoji that is being shown into the page. Move mirror, I can do that. Let's do this. Why not? So launch the experiment. So what it's going to try to do, I'm going to stand up and I'm going to try this, is it tries to analyze my positions, and then it tries to find a similar image for that on the web. There's no audio, so you can easily see it. So it's only for one person right now at this point. Let's see. There we go, making a GIF. Let's try it. Next, allow. So of course you have to allow your camera. And let's see. All right, it did work. So all of this, as we talked about, all of this is on local machine. None of this data is being sent. And you can try out different types of models. So this is the full body pose detection model, but there are also models that are available. Let's see. There's a face mesh model that you can use to understand the expressions on a face. So face landmark detection and simple face detection. So this one you can use to just detect that there's a face. And with this one, you can detect different variations in the face. So like right here, you can see like different points around the face that a person has. Again, all of these things are available on GitHub, all open source. So right here, you can just go to TensorFlow TJS models. All of these are open source, and you can see other models in here as well. Yeah, try this out. Let us know how it goes. And if you have more questions, stop sharing. All right. Any more questions? Okay, can you recognize the scale in imaging? It's tough because, again, machine learning models are very good at certain things, but they're also dumb at some other things. So if you don't train a model to recognize a scale, a height, or width, and things like that, then it doesn't know that. So unless they're like very specific about the thing that they work upon, and as soon as the problem goes out of that domain, they're just not good at that. So of course, like if I'm training a model to generate music, it can generate music, but it can't draw. Humans are really good at that, but machine learning models are very single purpose right now. However, we as in humanity is working towards building general purpose models. And there has been some good work around that, where we have been trying to build models that learn one specific task and can be utilized for other things as well. AlphaGo was a really good model on that, where the model was trained to play Go, but then that same model was able to learn to play chess as well. And with that, and without any training data from the user itself. So that same model was able to do other things. GPT-3 is a good example of that, though not the same principles. It's the same variation where the trained model is to just generate text. But when you're generating text, you can get a lot of different variations where generating text could, of course, mean a conversation, but we do write our code using text as well. And that code can also be generated. So with GPT-3 model, you can actually start generating code as well. For some examples, I don't know how well it works, but it does work. We have seen a lot of demos around that. So of course, people are working towards building general purpose models, but it's just a little bit far off right now. I don't know when we will get there, but we'll see. Awesome. Thank you, everybody.
All right. Thank you, Vikram. That was an awesome and interesting talk.
Awesome. Thank you.
So we're going to finish now. I want to point out a couple of things. One is if you're interested and if you're new to GDG, just join any GDG close to your neighborhood or close in your area and participate and help them make great events. I mean, we have organizers all over the world. We have GDGs all over the world. They need help for sometimes. They always appreciate any support you can give them. And if you have an idea or a thought you want to talk about, just contact them, and then they most likely, or they will be very open for you to participate and show, maybe a demo or a lightning talk or any of that sort. That's always welcome. This event was the first one, as I said before, in the intro, it's the first online virtual DevFest we ever did, and it worked really amazingly well. There's no question about it. I mean, it was almost perfect. There was a slight glitch with my microphone, but that was it. And for that, I want to thank Corinna and Kubra, because they worked diligently in the heart behind the scenes, and they made everything happen. So again, thank you very much. Also thank you to Vikram. He not only did this great talk right now, he also ran the track one and organized that. So again, thank you, Vikram. Glad to have you here, and let's see. A few more thoughts. If you still have questions or anything, use any of the channels we have. It could be on Meetup, it could be on the GDG community, and it could be on Twitter. right? So if you want to have anything, you want any information, you want to know something, you want to contact the speaker, maybe the simplest way is to use GDG, community site, or use Twitter. The tag is, or not the tag, but the handle is at GDGSV. We'll send out a message, a thank you note on Twitter, and that will contain all the handles of all the speakers. So that should allow you to actually get together with them. So now let's join everybody back, the whole team. And I think we can close here and say goodbye to everybody, and either have a nice day or enjoy your sleep, or wherever you are in the world. I mean, maybe do something. I will probably go cycling right now, but whatever you plan, enjoy, and see you soon.
Awesome.
Right.
Thank you, everybody.
Take care.
Thank you so
Bye-bye.
much. Bye, everyone.